Alrighty, welcome everyone. Hey, it's time to do a little recap, so to speak, on a couple topics we've been talking about on the NonSequitur show, and a few that we haven't even talked about yet. So they're not really recaps, even though I think we brought them up before on the show. So recently, as you guys can tell, I've gotten back a little bit more into the younger creationist stuff that I used to do years ago until other people came along on YouTube and did them a lot better than me and kind of pushed me to the side. All's fair. I respect that. And I realize that they do a better job than me. And so I have absolutely no problem with that. However, it doesn't mean that I don't talk about these things at all. It just means that, when it comes to making really, really good videos demonstrating why young earth creation is false, there are just better people at it than I am. Okay. I'm quite aware of this. And I do promote those channels. If you want to check out some things like Pelagia, Simon Dan, let's see who else, Hereticals, just for the heck of it, because I think Chris is probably out there somewhere. Check out those channels. But when it comes to like this channel, what we do is we talk about the topics, right? So these are not channels that are dedicated to make a very specific video to say, okay, here's why something's wrong in an easily digestible form. They're just not, and I apologize for that. But that's not really how these any of my channels has ever been. I tried making videos like that back in the day, and they were okay. But they weren't anywhere near the quality that I would have liked or that I would expect from people that actually are professionals in these topics, or at least very, very, very knowledgeable. And I just have a basic understanding for all practical purposes, sufficient enough to at least discuss, but don't rely on what I say as some kind of expert opinion. I have had obviously biology, physics, math, but I mean I've had just the undergraduate level stuff, nothing spectacular, certainly nothing that I would ever want to get back into academic wise because it's hard. But I did, have to take this stuff at one time. So I thought maybe I could go over a few things that have been coming up lately again, making the rounds, so to speak, on young earth creationism. Let me know if you guys can hear me okay. I'm not doing a video today, just not choosing to, but you can hear my sultry voice and my dulcet tones when I talk about these different scientific topics and hopefully understand them. But I do want to start off with one thing before I even do that, because this is recently. This is like literally just happened a few minutes ago. When I talk to earth creationists, especially, let's say I'm having a comment section on YouTube on somebody's video. I'm not going to go into great detail on anything. Why? Because I've learned a long time ago it's unproductive. They're not interested in learning the topic. They've already had their minds made up. They're not interested in anything you have to say. It's just sea lining, and it just is wastes everybody's time. So I don't really bother in YouTube comments getting any real technical or anything like that, or talk about these topics in any real depth. Excuse me. But I do like listening to what creationists have to say sometimes, because they say the dumbest things. And one of them literally said the dumbest thing I've ever, almost ever heard. Just recently, just a few minutes ago, somebody had asked me, they said, can you know anything or be certain about something? And I was like, yeah, well, I can know about a priori knowledge, right? I can say that for all of x equals x, which is the law of identity. That has to hold true in all possible worlds. There's just not a possible world that fails. And he had asked me, he's like, but have you observed that everywhere in the universe? I mean, literally, it's just right here on this video that I responded to. They're asking me to, in various comments, to observe a priori knowledge. Now, most of you out there that have any kind of understanding of basic philosophy, epistemology, and logic would understand the absurdity of that statement. While there are some a priori facts you can observe, it is certainly not necessary to observe an a priori fact. That would make it a posteriori. The fact it is a priori means you can know it without observation, without empiricism. It means you can understand it analytically. Okay? X equals X is an analytical statement. It is known a priori because it's something you don't need to derive. It's nothing you need to go out and observe. It's nothing you need to go experiment or do empirically. It is a fact because it's a mathematical relationship you can know mathematically and analytically. Just say, have you gone and observed an a priori fact makes absolutely no sense. Can you? Sure, but do you need to? Of course not. Because you already know it. If you know it, then it has to be true. In order to know something, it has to be true. If you know P, then P must be true. There's no getting around that. And I said that in a Facebook group, and I had both the atheist and theist lose their mind. And all I said was, if a theist knows that God exists, then God must exist. That's a true statement. That is a logically true statement. And they didn't understand at all what I was saying. Because again, knee-jerk reactions. When we're talking about Facebook groups, you're talking about YouTube comments, people generally are not in any kind of real mood to even have a open-mindedness to understand what you're saying. So they just took what I said in a knee-jerk reaction. But anybody who knows logic knows what I said is true, or epistemology. If it is the fact that you know something, then that is true. There's no way around that in justified true belief. I hope that makes sense to everybody out there. It's just basically saying that if you know it's to be true, one of the preconditions for it being knowledge is that it must be true. Therefore, if you do know it's true, the precondition of it being true has already been met. I hope that makes sense to everyone. All right, but we're not talking about philosophy, even though this is 3M philosophy. We're going to be talking about science here. But anyways, I just thought that was hilarious. I was asking the guy, do you know the difference between a posteriori and a priori? And clearly they don't. But this is one of like two people on this particular web page that for some reason, thinks that I'm going to go into a treatise of explaining 100 years of biology in a comment section. It's just absurd. These are not concepts where you can just get bits and pieces of it and truly have an understanding of it. And this is what I think younger creationists and flat earthers rely upon. They rely on the fact that these are very technical, very complicated subjects that most people have to take some form of schooling to really understand, at least the basics. You're never going to find a flat earther who has no education whatsoever understanding general theory of relativity, or able to understand, Einstein's equations, or even basic things like math. I mean, they just don't get it. So even when you learn math, you start off precept upon precept. You don't go into mathematics starting with calculus or matrix theory. You go in starting with basic arithmetic and basic binary relationships and basic functions. These are how you learn math. And then you get into more complicated maths, like pre-algebra, algebra, pre-calc, calc. And you learn precept upon precept. Because if you go into calculus and you don't even know how to do algebra, you're not going to go very far, right? So it's just very difficult for people that have never had any understandings of these topics to explain things to them. And they use terms that they think they understand that they don't. And you really do need an expert, which is clearly not me, but an expert to come in and kind of parse it out in a way that they can explain it to somebody who is listening in going, well, this person sounds like they know what they're talking about, but the expert goes, yeah, but they don't. And because the expert does know what they're talking about. And then you could argue, well, I've got two competing experts. I have a young Earth creationist and I have an old Earth creationist, or I have an atheist, and they're all giving me different information. Okay, then you just go to the objective facts of the matter to be had. And you'll find every single solitary time, without fail, that the young Earth creationist has distorted the truth or it outright lied. There's been no case that I've ever seen on any young Earth creationist claim where they have gone out of their way to distort the truth or outright lie. There's just been none. If you guys can think of one, let me know. But I certainly can't think of one. So let's kind of like talk about some of the subjects we've already talked about so far. On the NonSequitur show, we started talking about helium diffusion rates. I've had Dr. Henke and Dr. Loechelt on 3 times now, twice on this channel and once on the NonSequitur show. And they're just brilliant. They're absolutely brilliant. And they have written quite a bit on this topic of helium diffusion rates. They've written for Talk Origin. They've written a paper in a actual scholarly journal. Sorry about that. I'll be sharing that in a few here. And so they have the information, they have the data, and they have shown that the young Earth creationists made fundamental mistakes. And those young Earth creationists have recognized some of those mistakes, but they've never corrected any of them, which is really, in my opinion, quite telling, that they will not correct their errors. So what we're going to be talking about is young Earth creationism is false. By the way, my other videos where I said 10 reasons why Christianity, and I mean classical theism, is false. People are like, well, that should just mean that you should say you believe that. Well, when you make a statement, you are making a dosastic statement. It's the same thing. If I say young Earth creation is false, it's clearly implying that I believe young Earth creation is false, and I'm giving reasons. So when I make the statement young Earth creation is false, I'm giving you reasons why it's false. That's how you argue. Then somebody come along and say young Earth creation is true, and here's the reasons. We're both arguing our positions, right? So it's perfectly fine to make a statement, young Earth creation is false. That's not a absolute statement as the same as it is an absolute fact of that has been proven young Earth creationism is false, because nothing like that can be proven. Things are not proven in science. But has it been demonstrated conclusively? Yes. Young Earth creationism has overwhelmingly been demonstrated to be false in multiple different forms of science and disciplines. That is a factual statement. But again, just making a statement that you think something is true or false is perfectly fine. You don't have to caveat it with a belief. It's automatically understood as a connotation that you're making a dosastic claim, not a knowledge one. All right. All right, so we're going to be talking about human diffusion rates, distant satellite problem, and one of my favorites, human chromosome number 2 fusion, which goes back, oh man, that we've had some discussions on that. Excuse me. So let's start off with helium diffusion rates. So as I said, Dr. Henke wrote on Talk Origin extensively on this, and it's a really, 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 really good paper that he wrote. Well, I'm sure I more like an essay, I guess. But this one right here, this one by Dr. Loechelt was actually published. It was published in an actual scholarly journal. And he makes some very, very poignant observations that young creationists made some mistakes. Now, again, I don't want to get into the weeds of this topic. That's what I think maybe happens when we start talking about it when we have 2 PhDs on, because they're so smart that, you know, it's hard for them to probably relate a lot of these technical concepts that they took, you know, decades of our lives to actually learn. So let me first, you know, I'm going to put a shout out there, everybody. Hi, everyone, by the way. We've got my lovely moderators, Kano and Chemo and Autistic and April. We've got Best of Truth. Hi. I emailed you, by the way, if you want to get me back. I got Pheasant. Hey, Pheasant. Lieutenant Stan's Legs, and then Frida. And I think Chris was out there earlier. So put a shout out to all you guys. All right. So, accelerated decay in the Live New Experimental Channel. So let me kind of break this down of what we were actually talking about and why. It is well understood, even in the RATE program, and RATE stood for Radiological Isotopes and the Age of the Earth. Basically, RATE was a program that the young Earth creationists had in order to give scientific evidence and justification for their belief that the Earth is only 7,000 years old. Now, you have to remember, and this is very important, science does not start off with a conclusion. Science starts off with a guess. Yes, a guess. If you think otherwise, you don't know science. Science starts off with guessing. I guarantee it. Any scientist who's worth a lick knows that's the case. Any of us who've done any kind of science or any kind of logic, we do a lot of guessing. I've done it in my life. I've done it both in theory and practical. You know, when you're operating a nuclear power plant, you have to first guess what's kind of going on, and then work through that and make it into a hypothesis, and then make it into something is this really the case, right? You have to sometimes guess. There's nothing wrong with that, but these are educated guesses. And so when a scientist makes an educated guess, they start developing it into a hypothesis that's testable. That's what they do. And then they try to find information and data that actually overcomes their theory, that will nullify it and disprove it. Because if you can find defeaters to your argument, then your argument isn't sound, right? It isn't correct. You'll see this a lot in math. There's something called the Collett's conjecture, which basically is a very simple mathematical conjecture. Anybody can understand it. It's basically all you do is if you have a number and the number's even, you call it a seed number, you divide it by 2 if it's even. And then whatever number you get, you divide it by 2 if it's even. If it's odd, you add 3x plus 1. And you keep doing this over and over again. This is just the algorithm. Even, divide by 2, odd, 3x plus 1. And you'll find that for the first 10 to like 67 numbers, some quintillion, trillion, billion, zillion, zillion numbers, it always comes down to a cyclic repeat of the numbers 4, 2, and 1. So 4 is even, you divide it by 2, you get 2. 2 is even, you divide by 2, you get 1. 3 plus 1 is 3, plus 1 is 4. You go back to 4, and you just run up in this loop. Now, the Collett's conjecture says that will be true for any number. However, it is not proven, and it may not even be provable. But people started off by taking, just guesses initially. Okay, let's take a number and stick it in there. Okay, well, 12, yeah, 12, it works. 10, it works. 115, it works. And eventually, you run out of a space through just simple guesses because numbers get so high. Or I mean, after, a few thousand, guessing is kind of done, right? You need a more brute force approach. But you only have so much computing power, and believe it or not, numbers are infinite. There's an infinite amount of numbers in the cardinal set for the real numbers. So you can't test every single number. So you need brute force attack to it. But if you found one number, just one number where it didn't go down to a 4-3-2 loop, if it somehow either chained back on itself or it just blew up into infinity, you would disprove the Collette's conjecture and probably win a Nobel Prize, or at least a Fields medal. You want to win a Nobel, but you would win a Fields medal. I'm sorry, excuse me, I still have my cough. And so it would only take one example to disprove the Collette's conjecture. Oh, and by the way, Landon Kurt Null is out there, who is an absolute genius in math, and he might have a lot to say on the conjecture. I don't know if he's ever wasted his time trying to prove it, because I hear that that's a complete, I guess, waste of time trying to prove it, because it's just so many people have tried and they've all failed that we just don't even have the mathematical ability to do it. But I think that Landon would agree that if he found, I mean, he has 2 world records in math we did on finding Mersenne primes. If he found a counterexample, just one number that didn't follow the Collette's conjecture, Landon would be more famous than he actually is. I mean, he's famous, don't get me wrong, but I mean, he would be one of the top mathematicians in history. I would think. I mean, that would get him noticed very much. I mean, he already is noticed, but yeah, negative numbers don't apply to the Collette's conjecture. But anyways, I just thought I would throw that out there, because that's how science works. You have to find some disconforming evidence to your hypotheses, but they do start off with a guess. And so this was a long way to get around the fact that younger creationists are trying to explain something starting with a conclusion, which is not science. Right there and then, they are outside the realm of science, because they start with a conclusion rather than starting with a hypothesis. I find that to be dishonest. And by the way, Landon, I sent you some email and a bounce back. I had to DM you on Twitter, which I know he doesn't use Twitter, but send me something on email, because your email wasn't working. I was trying to reach you on something. We have a super chat. Kawasa 10,001. Last show was pretty good. I'll take pretty good. Pretty good is good. I can't believe I'm saying this, but Side 10 was actually enjoyable. Good fun stuff. Yeah, Side 10 is personal. I mean, he really is. I mean, he's a nice guy. I mean, he plays part of a character, as clearly I think all of them kind of do. G-Man plays a character, but Side 10 has been nothing but kind to me. Nothing but kind to me. And so I do appreciate that. But Best of asks, okay, can you give me a good definition of a creationist is? A creationist believes that the universe was created by some kind of intelligent agent, whether it be old Earth creationism and the universe is 13.8, 13.9 billion years old, or that it is young, like 7,000 years old. But both of them believe that there's some kind of creator involved. There's just some kind of agent that actually created the Earth, the universe, etc. So... Oh, he's worked with Eridos on it. Okay, I remember. Is it Paul Eridos? Is that his name? I need to Google stuff. Was that his name, Paul Eridos? Eridos wrote on the conjecture, but he didn't ever. He never. He gave up. If I'm not mistaken, if I remember correctly. So, but I mean, most of them have realized that it's kind of a fuels. Yeah, Eridos is the one that said we don't actually have the tools to do this, even though, hey, but here's a fun fact. Fermat's last theorem, they didn't have the tools either. What's his name, who won the medal for it, actually came up with his own mathematics to do it. I mean, he actually came up with his own mathematics to solve that particular problem using Ricci flow, which I think was a very unique approach. But anyways, but yeah, so I think, Landon, though, the point that I was getting at, I think you would agree, is that all you would have to do is find one counterexample. Right, one counterexample, and the Collette's conjecture is done. Over. Yeah, and they've looked for counterexamples in the first 10 to the 67th power and not found any. But does that prove that there isn't one? No. No, in order to prove that there isn't a counterexample, you need a mathematical proof, or you need to find one. And maybe one day they will. Absolutely. But right now they don't have that, and I think a lot. This kind of relates to younger creationism. Is younger creation would point to it and go, "Oh, well, you haven't proved this yet. Therefore, there's no reason to believe it's true." But they neglect all the data that points to the reasons we should think it's true. That we've done the first 10 to the 67th power of numbers, and they've all fell into the Collette's conjecture. Does that give you justification to believe that it's true to all numbers? Yeah. Does it mean that it is? No. It doesn't follow that it is, right? You cannot say it is true for all numbers merely because it's true for the first 10 to the 67th power that we've viewed, But you certainly can use that as a justification condition. Failure to find a counter is not a proof, but failure to find a counter is a dosastic justification. For a person who wants to believe that the Collatz conjecture is true, they can use that as an example of, hey, we've looked at all these numbers, we haven't found a counterexample. I can extrapolate by induction that there probably isn't a counterexample. I believe there's no counterexample. But that doesn't make it true. And by the way, I don't have that belief. I don't have a belief on it one way or another. There could very well be a counterexample. There's been other conjectures that they found counterexamples in very, 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 very high numbers. But it took time to get the computing power to get to those high numbers. So there certainly might be a number out there that violates it. So I have no belief on it either way. But I'm just saying, if a person wanted to believe that it's true, they certainly could be justified to do so. Stuart Hamilton. Hey, Stuart. Been a while, buddy. He says, for 20, thank you. Oh my gosh. Thank you, dude. He says, to understand young earth creationism is practical in the United States, it is necessary to first accept that it is first and foremost a ministry. That's true. It is a theological argument to sell an entirely unrelated idea, specifically Christianity. You are 100% absolutely correct. I absolutely agree with that. Young earth creationism is a religious theological movement. It is not science. It has never been science. It can never be science the way they operate, because they start with a conclusion and they make them sign waivers or statements of faith that say if any science violates the young earth creationist model or view, they have to reject it in its entirety by fiat, regardless if it's veridical or not. Regardless if it's true or not, that doesn't matter to them. All they want to do is promote their theological arguments. They want to promote Christianity. They don't care about the science. Science to them is just a tool they can use and rely on the fact that most people don't really study these topics at any real depth. Many of them don't even have any superficial or rudimentary understanding of science, and the young earth creationists, I think, take advantage of that. I really, really do believe that. So, anyways, let's get back to the accelerated nuclear decay, because, I mean, we took a tour, but hey, you know what? That's what we do on this channel, right? Should be used to that by now. By the way, yes, the StreamYards is available if anyone wants to pop in. It's voice only, no cams, but if you want to pop in, absolutely, it's pinned to the top there. All right. If you hear me mute for any few seconds, I'm coughing. I apologize. Yeah, still haven't got over that nasty cough. It's been coming and going lately. I got to go get some medical stuff. Get some allergy pills. All right. So, anyways, long story short, the creationists realized that all the data for the chronology of the age of the Earth using radiometric dating does have an appearance of age. They have admitted this. The rate program did admit this. They have said, yes, according to various types of radiometric measurements using uranium, plutonium, thorium, strontium, argon, krypton, whatever, they do seem to indicate an Earth that's, billions of years old. Now, they say, okay, while that is true, we can explain why it looks that way. And one of the things that they posit to explain this is called accelerated nuclear decay. This is just a hypothesis. It's a guess. It's a guess for them. The problem is that they do not have any single solitary testable evidence for it. They have not made it into a hypothesis yet. It's not a hypothesis. It is at the guess stage, because they have to try to show that this is not just plausible, it is something that actually is true. But there's no indication that it's true. But what they did was they had one particular area where they thought they had some evidence for this, and that was in what's called helium diffusion in zircon crystals. They were looking at the data and they said, oh, look, this does indicate an evidence of an accelerated nuclear decay. And they were trying to argue that the helium diffusion rates were more accurate to describe the age of the Earth than actual chronometric dating using isotopes, which is just insanity. There's no reason to think that. We know how accurate radiometric dating is. We understand the physics behind it. The physics involved in the helium diffusion rates is complicated, much, much more complicated than anything you ever learn in radiometrics. I took radiometrics. I literally worked around nuclear power plants. I trained people operating nuclear power plants, even though I don't remember much from it and I don't have a claim to. I did have to learn about the physics of radiation. And yes, it's complicated, but it's well within most people's reach to understand. I did, and if I can, most people probably can. But the helium zircon diffusion rates, you need to require an expertise, a person who's highly trained in this particular topic, who's had the education. which Dr. Loechelt has had. So he is a foremost expert in order to talk about this particular topic. So he had written this explaining some of the errors in the view of the rates program, and especially Dr. Humphreys and other people that weighed in on this. And just to kind of, I'm not going to read the whole paper for you. It's in the video description. But basically what he points out is that the models that they used in order to get the numbers they wanted were highly flawed. There was two basic curves on these diagrams. Okay, this is called a Arrhenius plot, and basically an Arrhenius formula. We didn't much talk about it, but basically what that formula is how fast things react to each other. It's an exponential formula where you have a relationship between the natural log, natural log of E, and you have it raised to what's called the activation energy divided by the ideal gas law in time. Ideal gas law is a constant. Anybody who knows about fluid theory has looked into the ideal gas law. It's just a number. It's a fixed constant. Time is a variable. Activation energy can change, and heat can change. These two things will change the Arrhenius plot. These two things will change the formula, the rates, because if you add heat to a system, then the frequency at which the molecules or atoms are going to interact with each other is going to increase because the kinetic energy is increasing. They're getting more energetic. They're moving around more. They're getting more collisions. This isn't what we didn't really talk about in the NonSequitur show, and why I wanted to talk about here, because we didn't really explain some of the science behind it. And so hopefully this will give you a little bit of understanding. There's only two things really that'll change the interactions of particles, excluding time. Obviously, time. The more time you have, the more interactions. But without time, the two things that'll change is, one, the frequency of collision, which is going to be based upon your kinetic energy, and what's called the macroscopic cross section, which is basically saying how big of a target does this appear to another particle. Particles traveling at different speeds will have different Barn ratios and say different appearances of how fast something's traveling at them. And so this all has to be taken into account, whether these particles are actually going to interact or not, and they're going to scatter or they're going to absorb. So there's what's called the macroscopic cross-section for absorption. There's a macroscopic cross-section for scattering. These are all mathematical terms that you would have to know to really understand some of the solid-state physics involved in this. But in a nutshell, all you really need to know is the more heat you add, the more energetic, the more you're going to get helium diffusing out of the rock. Because if you have these what's called defects, these line fractures that are near the surface of a rock, obviously you have a less path to go through. And so if you give it more heat, it's going to get more energy to really to leave that crystal through these fractures, factors, or what do they call it? Fraction, a fracture. Geez, these fractures. And so the other thing you do is change the activation energy, and the activation energy is actually changed by these defects. So the more defects you have, the lower the activation. And what an activation energy is basically how do you get from the reactants to the products. In a chemical reaction, if I have a certain amount of two reactants I put together, they're going to interact with each other to produce some kind of product. The Arrhenius formula tells you the rate at which is going to happen, and if you lower the activation energy to lower what's called the threshold of the reactor to the product, then it requires less energy, less heat to make these reactants go to the product. And so this is what an enzyme would do. An enzyme is some kind of agent that lowers the activation energy in this formula. And so there's two things going on. There's lowering of activation energy by these defects in the low domain model, and there's heat being added to the system, which is having an overall major effect in the high domain model. The modeling for low temperature in the low domain and the modeling for high temperature in the high domain are not the same model. This is what Loechelt was trying to explain, that Humphreys and the rate program did one model, and then they brute extrapolated. I'm not against extrapolation, but they just took one model and extrapolated, not taking into account there was two different models that produced two different parts of the curve. You can't do that. You can't do that. That's just not how the modeling would work. If we did that, then nothing in science we have based upon solid-state physics would work. We know the modeling that they use doesn't work. Why? Because the modeling that Loechelt works with does work. Why? Because he designs these things. I mean, transistors wouldn't work if we didn't understand how solid state mechanics work. And so that was the big thing that he was trying to point out. And so these were the two-line model. Excuse me. I don't know if he's got it in this paper or not. This, by the way, this model right here actually was a different borehole that did come back with an age of millions of years old. About 75 million years old or something like that. It was between around 50 to 100 million years old in the nominal region here on the borehole. So at about 130 degrees Celsius, it did come back to 75 million years of age. The rate program never addressed that. They never explained why that was the case, even though that was a well-studied paper that gave all the evidence that the Earth is millions of years old. Rate had no argument against it. The argument they were making was against what's called the Fenton Hill Zircons, and the arguments they were making were great grave errors in their methodology. Another error that they made, which Dr. Henke was really talking about, was that the rocks they thought they had in Fenton were not the rocks they actually had. The rocks that they had were one, these zircons were produced very different places along the bore when the borehole is straight down. These zircons could be produced at different temperatures, different pressures, and you'll find that zircons produced at different temperatures, different pressures, at different locations will have different consistencies, different properties, different impurities, different surface defects, and so you don't know exactly what region you're getting at for the zircon, because some could have been moved around, so there could have been transport. You're not quite sure. You have to understand the makeup of the rock to know which exactly rock you're looking at to get the right formulas to be used. They didn't do this. They literally just looked at the rock and said, it looks pink, therefore it is, and they named it. They named it grandurite. He actually just named it, Jimenez grandurite. You're not allowed to do this, by the way, in geology. You cannot just create your own rock names. In order to create a name, you have to go through a very specific process. Humphreys didn't do this. He just took it upon himself to make up a name, and he called it Jimenez grandurite. And they were arguing that it was a there was an isom. They were arguing that it was a what was he? What were they arguing? Because it ended up being a metamorphic rock, right? But I don't remember if they were arguing if it was sedimentary or not. I have to look this up. I want to make sure I tell you guys right. No, there was igneous. I think they were, yeah, no, you know what? It was igneous. So they were arguing that it was igneous rock called grandurite when it actually was called gneiss, which is a type of metamorphic rock. And the formulas you would use to calculate the the helium diffusion would be completely different depending on your rock, obviously. It also depends on your surface area. They got the formulas wrong for the type of crystal structure it was. If you have different surface areas, you're going to have less diffusivity. You're going to have less escape of helium because you have less surface area. Surface area is very much lower activation energy for the helium to escape. It's easier to escape right by the surface than it is deep down into the crystal. That's just be common sense. Something that's buried deep is harder to get out than something sitting right on the surface, right? So if a crystal has more surface area, helium should diffuse out of it easier at the surface area. So those models have to be taken into account. They didn't get that right. Also, Humphreys didn't get his math right. Now, this is the formula right here. This is the Arrhenius formula, and you can plot it linearly. The reason you can plot it linearly is basically just if you take natural logarithm of all this stuff, you get a linear formula. It's called mx plus b. If you ever taken linear equations, you'll find that a line is defined as mx plus b, where you have some constant m, which is your slope, times some x plus your offset, which is your b. So that will give you the line formula, right? What is it? Well, I'm sorry, m isn't your slope. That gives you the slope. Line formula gives you the slope, right? But that is a linear formula. If you ever see mx plus b, you know you're dealing with a line. You know there's not going to be any curvature in that, right? Because actually, it gives you the slope intercept. There you go. Why is the slope intersect? So m is going to be your slope, right? Then some variable plus your x, your b, which is your x-intercept. I haven't looked at this stuff in ages. It's your x-intercept, isn't it? Landon? Got to make sure I get the math right here. I don't want to steer you guys wrong because unlike young Earth creationists, I want to make sure that I get it right. And I'm just not looking anything up other than the. Is it the it's the y-intercept? Yeah, it's the y-intercept. That's right. All right, so mx plus b gives you the slope times x plus the y-intercept, and then y will be the your slope intercept. So that's a linear equation. So basically, just by taking your natural log of all this, you'll get a linear plot, which is fine, no big deal. But what Humphreys did was he derived this formula. There's it in here. So this shows you the two slopes. You have the low domain temperature slope, which was, I believe, around, if I remember correctly, around 65 degrees Celsius. And then you had your high intercept slope, which is around 180 degrees Celsius. And so these actually produce two slope lines, sure, but the actual data on the intercept is two curved lines, or two lines that have a curve. This is called your intermediate region in the middle. I don't know if you can see the mouse. Let me put my mouse on here. Oh yeah, I should be able to. Yeah, it's a y-intercept. I had to think about that for a second. It's been a day, but yeah, it's the y-intercept. And so these two lines right here will meet in the middle in the intermediate temperature region. These modelings are all different. You can't just put two lines of diffusivity together like that. It doesn't work mathematically. You cannot add diffusion rates. This is something that Humphreys had to learn from Dr. Loechelt and admitted he was wrong on this. He didn't understand, because he's not a solid-state physicist, that you cannot mathematically add diffusion rates. It doesn't work that way. And the way he did it was even worse, because Dr. Loechelt had asked Dr. Humphreys, how'd you arrive at this equation? And if you go down to the appendices here, he arrived at this equation. And Dr. Loechelt even says, therefore, I was a bit surprised that I saw the following equation in the rate literature. This equation appears nowhere else because it's nonsensical. It does not in any way describe any kind of system, nor will it ever describe a two-slope system, because this produces a line. It doesn't produce a curve, two curves, or a curve anywhere in there. It doesn't have two slopes. And so he proves this by taking this natural logarithm of both sides, and you get a formula b minus a over 1t, which is again reminiscent of mx plus b. You could see if you just move this around, you'll have mx plus b. You have some variable times x. It'd be minus a 1 over t plus b, but b would be your y-intercept. So it's clearly that this is going to produce a line, not a two-slope curve. And so when he asked him how he derived this, Humphreys showed him this derivation right here, and he just basically took the natural log of everything. Unfortunately, he didn't understand that natural logs do not distribute over addition. The natural log rule for distribution is only over multiplication. And this is what Loechelt was really surprised, because Humphrey has a PhD in astrophysics. He's had advanced maths. Distribution over addition works for things like multiplication, right? You could distribute multiplication. You can only distribute one order higher. I can distribute, if I remember correctly, one order higher. So I can say, like, you can distribute multiplication over addition or exponentiation over multiplication, but I cannot do exponentiation over addition. You can only do one order higher. But when you do distribution for a logarithm, I can only do, if I have log a plus, parentheses and some quantity a plus b, I can't just distribute that. There's a different way of actually figuring that out. But if I have logarithm a times b, where a times b is some product, right? So I have logarithm quantity a plus a times b, then I can just say it's ln a and ln a, I think it's minus ln b if I'm not mistaken. Right. So, I mean, that's just a law of logarithms, right? It's just a way of figuring out logarithms. I don't remember if it's plus or minus. It doesn't matter. But the point being is, if you want to distribute over ln, where you have a times b, it has to be a times b. It can't just be a plus b. So that was a mistake that he made in a very simple way, that you cannot just take a logarithm when you have something like one domain plus another domain. And so that's what Loechelt was pointing out, that his math was just simply wrong. And Humphreys has admitted to that. He has admitted that he did get it wrong. His philosophy is just, what does it matter? I'm not even joking. His philosophy was, what does it matter? He doesn't think it's any big deal because he said, well, I didn't even use this in my paper to Loechelt, which is true. He didn't. But Loechelt's point was, well, you came up with a model that's wrong. You came up to justify that model using bad maths, and you don't see a problem with this when you have people reading your stuff, taking what you say at heart because you have a PhD in astrophysics, and not correcting it and letting people know that you were wrong. I find that to be dishonest, you know. And I got nothing against Humphreys. We've always got along, and he really hates being called dishonest. He really does. But I don't know what else to say when you make a math error and you make a modeling error and you admit that you interpreted the mathematical model wrong. He told me that. He's like, yeah, I got that part wrong. But he said, but my math wasn't wrong. And then later on, he's like, yeah, my math was wrong. But, you know, it's like, if you don't go back and correct the 2000 stuff, you know, from 2002, 2004, and things of that nature, you don't go back to creation.com or CRI or AIG and said, yeah, hey guys, hey, look, I goofed. We need to edit this and update this because it's not reflecting new data. Science reflects new data. They don't. They simply don't. They don't go back and correct anything. Hey, Lawrence, how are you? And so that I find that to be kind of just very telling, because Humphreys and Jensen and all those guys, I just don't think they care whether somebody understands the science or not. To them, it's all about promoting Christianity. It's all about promoting young earth creationism. That's it. The science just is a vehicle they use to try to obfuscate and try to equivocate and try to manipulate and try to lie to people, because some of them actually do believe the ends justify the means. I know Nathaniel Jensen absolutely believes that. He has said that he is perfectly fine lying to people using his Harvard degree if it makes them come to Christ. It's a ends justify the Machiavellian type approach, but it's ends justify the means. He believes, and you can ask him, he said this. This is not me making this up. He has said that if somebody's saved, then it's fine. It's because he doesn't think it's any big deal. He doesn't think lying for Jesus is a big deal, because if it convinces somebody and they're saved, that's the bigger picture. I have huge issues with this, obviously. Academically speaking, scientifically speaking, ethically speaking, I have massive amount of concerns with that. I would never want somebody to leave young earth creationism because they've been lied to. I would never lie to somebody. And if the end result was them leaving young earth creationism, I couldn't do that, because they would have left by false pretext, and it wouldn't be something that may even be solidified with them. They can fall back later on. If they find that they were lied to and that the information they got was incorrect, they might go back to their old ways. So it doesn't make much sense to me to lie to people in order to try to get them to change their position. Okay. But anyways, that's kind of what was going on with the helium diffusion rates, what Loechelt was talking about. And by the way, I was very honored, just to kind of toot my horn a little bit. He does mention me in here a couple times. He cites my, here we go. He said, I'd like to thank Steve McRae, that's me, for his support and encouragement of this work. Kevin Henke and John Fleming assisted the biography, and yeah, so I mean, I was honored. I was so honored that he mentioned me in this paper. This was in the philosophy of science and Christian perspectives on science and Christian faith, and then also down here, I think I'm cited here, right here, number 38 and 28, right? So there I am. I'm also cited on Wikipedia in Sunnyvale, California, believe it or not. And I'm cited because Landon, believe it or not. One of my videos that Landon was on, Wikipedia has cited. So I'm honored for that too. I don't know how that came about. I don't know who put it in there, but that's epic. So I appreciate that. So yeah, my programs do get some citations. I am literally cited in peer review papers, and this is peer review. This is not some creationist journal. This is not the Journal of Creation. I'm in the Journal of Creation as well, because Dr. Humphreys has mentioned me. But this is a paper that Dr. Loechelt went to the Journal of Creation, and they wouldn't publish it. The reason being because it refuted their findings too much. And they have that standing policy. If it refutes young earth creationism, they can't publish it. That's dishonest. And I'm not even exaggerating. I'm not trying to even overplay this. The reason why they didn't publish it is because it refuted their own position, and unequivocally so. So Dr. Loechelt went to Perspectives on Science and Christian Faith, which is a scholarly journal. Just because it has the word Christian in it doesn't mean it's not scholarly. There are scholarly works dealing with Christianity. There's a lot of atheists that are scholars about Christianity. And so it's still a historical subject, right? So they said, okay, sure, let's peer review this. They did. They were like, yeah, this seems to be in line with all the other data that we have, right? All right, so did that answer your questions about the helium decay rates? Because again, what they're trying to do in a nutshell is just say, look, we need to account for all this radiation over billions of years. When uranium decays down to lead, it produces these radiation particles, one of which is called a helium nucleus atom, which is basically 2 protons and 2 neutrons, but it's charged. It's electrically charged because it's devoid of 2 electrons. It's stripped away of 2 electrons. So we call that an alpha particle. Hang on one second. Okay. We call that an alpha particle, but all an alpha particle is helium. It's just helium that has been stripped by 2 electrons. It's highly charged. Highly charged means this also does a lot of biological damage. You don't want to eat something that's made out of it has alpha particle emitter. And so when you look at the uranium and you look at these decay products and things of that nature in these types of materials, you would expect there to be some helium. You would expect there to be some alpha particles in there or coming out of it, right? And it's stuck in the crystal lattices. These particles get emitted and they get stuck in these lattices called point defects, interstitial points in the crystal lattice where you have these helium atoms getting stuck in there. And when you add heat to it, they overcome that being stuck, right? They overcome the threshold and they exit the material. So again, by adding heat, you give them energy. They can overcome those point defects and leave the material, or you lower the activation energy and make it easier for them to do so by some kind of catalyst or by some kind of defect. And so you would expect there to be helium in there. You just do. And they say, okay, if all this helium's in there, that's a lot of radiation that was produced. That produces also, along with it, heat. And so they have to account for millions of years worth of heat. And they can't. They can't. This accelerated nuclear decay, saying, well, things decayed really rapidly, still doesn't get you out of the problem. It just produces a lot of heat very rapidly. It doesn't get you out of the problem at all. And they say, well, these are indications of accelerated nuclear decay. But when you get the modeling wrong, well, no, it's not. Because why? Because there's no sign whatsoever of accelerated nuclear decay. Matter of fact, let me tell you, if there was accelerated nuclear decay, our universe wouldn't exist, which I think is a pretty good defeater for the physics. Certain things are predicated upon certain mathematical consistencies, one of which is called the speed of light. And the speed of light happens to be very, very important in a lot of other natural constants. And some of these other constants have to do with the permittivity and permissivity of free space, of a vacuum. And so once you start changing around these constants, things don't go very well. You have atoms that can't form. You have stars that can't form. You basically run into a situation where the atom itself is not in a state of stability. If you look at a regular atom, people may not have thought about this, but in the atom, in the nucleus of an atom, you got neutrons and protons, right? Protons are positively charged. Protons repel each other because of the same charge. Everybody that's goes out of first grade knows that like charges repel. And so you go, wait, if there's positive charges in the nucleus and you have these neutral particles, we're just consider them as spacers at that point, how is it that the nucleus doesn't fly apart? Well, that's a good question. And the question is easily answered. It's answered because it is held together by a stronger force called the strong nuclear force. It's actually, in reality, it's actually a secondary effect of the strong nuclear force. Strong nuclear force really only deals with internal components of the proton, which is going to be dealing with quarks and the gluonic states between them. But there's a secondary effect that comes out of that there is greater than the radius of the proton itself that allows the protons to not fly apart. The stronger force, stronger nuclear force is stronger than any kind of electrostatics. If accelerated nuclear decay was a thing, those constants, like the strong nuclear force, wouldn't be able to hold that nucleus together. Electromagnetic radiation wouldn't travel at the speed of light. It just would affect all these different things. And so it's kind of funny that young Earth creationists want to posit something that, if it did exist, would most likely end up with a universe of just photons, probably, or something. Not even photons. I don't even know if photons would exist at that point. It just wouldn't be the universe that we know. It wouldn't be a universe that we could live in any way, shape, or form. And so I know they've addressed this before, and they're like, well, we'll come up with other stopgap measures at that point, right? They're like, okay, let's start here, and if even though we can't find evidence for the accelerated nuclear decay, we'll explain away the other things by other ad hoc explanations. And usually what they end up doing is exactly what Gentry did when it came to polonium halos. Gentry had to admit at some point, because he was just being crushed by the science, that he was wrong about polonium halos, that he just said, well, God did it this way because he did it by a miracle. They called it a singularity, a one-time event. That was his escape hatch. God did it. That's not science at that point. You're no longer doing science when you say God did it. You can believe that philosophically speaking, but you cannot use that in science. And so we see the young creationists doing that as well. Snelling did the same thing. Snelling had gone, well, God just did it that way. That's not science. This is what the difference between theology and science is. Science you can test and repeat and observe, and it meets certain types of conditions. And when you have creation science, and I use that term with scare quotes around the science part, this is definitely, I use scare quotes. That's not science. It's by no metric is that science, because one, you're starting with a conclusion, and two, you're eschewing any evidence that goes against that. You're just throwing it away by fiat. That's not science. So I just think it's kind of odd that they're really willing to just throw away all of science just because they want young Earth creationism to be true. But anyways, there's actually a formula out there. It's 1 divided by the square root of the electric permittivity times the magnetic permissivity. That formula, dealing with the permittivity and permissivity of free space, is a formula that will always give you the speed of light. That formula will give you the speed of light. Now, if the speed of light changes, those percentages of permittivity and permissivity change. Or if one of those things change, the speed of light changes. And you have a problem. You have a problem because now every other constant that relies on this, the gravitational force, the strong nuclear force, everything that relies on a natural constant is now been disturbed. And as a matter of fact, the young Earth creationists know this because they have an argument for it. They call it the fine-tuning argument. So they're willing to throw away one argument to make another argument. And I find that to be extremely weird. So, what's funny is at one time I put in Wolfram Alpha the formula for the speed of light using electric permittivity and magnetic permissivity. And I was like, I'm curious if I just threw what these constants is for the electric permittivity constant and the magnetic permissivity constant, if I just threw them into the formula here and took the square root and took the reciprocal, how close to the speed of light would it be? And you know what? It's dead on almost. I mean, obviously, the more higher value you use, the more closer you're going to get to the actual value of C, but you can definitely, it comes up to close to 300,000 miles per hour. It should be kilometers per hour. So 186,232.16 miles per hour, give or take, or just shy of 300,000 kilometers per hour, 299 something kilometers per hour. We know that this is by definition what the speed of light is. Matter of fact, the speed of light is one of those rare things that's defined by a number, and this is a fairly recent thing, by the way, too. They actually, if you ask what's the definition of the speed of light, it is that number. 299 whatever it comes out to be. That's the number. I will look this up. The speed of light is exactly 299,000 million. Sorry, not 100,000. It's 300,000, 186,000 miles per hour, but in meters per second, it's 299,792,458 meters per second, which is 299,000 kilometers per second. Yeah, the metric system's fun because, it's always, tens, right? So you have 10, 100, 1,000. And so, yeah, 209 million meters per second, give or take. It's a little shy of 300 million. But when you take the formula for the permissivity and permittivity, you get that number. There's a relationship there. Physics likes that. And young Earth creationists just want to throw that away. They just want to say, well, we don't care about that. The Earth is young. This accelerated nuclear decay has to exist. But if it does, you're violating the decay process. You're violating how long things take to decay, and that is contingent upon these types of constants. Matter of fact, believe it or not, E is a constant, right? The natural logarithm, E is a constant. You start messing with that, you have problems too. That's a mathematical constant. It's not even a physical constant. It's a mathematical one too. But any kind of physical constant you start messing with, there's problems. Pi is a mathematical constant. You can't just change that, right? You can't just redefine pi, all right? It happens to be a very specific number relating to the relationship between the circumference and diameter. You can't just say, well, you know what? I want pi to be 3.12. Even though the Indiana state bill once tried to do that. They tried to redefine pi, and some mathematician, when it got all the way to the Senate of the state, I'm not kidding, it got to the Senate, not just the House of the state, but it got to they were voting on it, and some mathematician said, wait, no, it doesn't work like that. It just doesn't, you can't do that. It just doesn't work like that. And to me, that reminds me of what young Earth creationism is all about. They're trying to do stuff like redefine pi like that. They're trying to just change things so fundamentally that when you have these experts like mathematicians and physicists going, no, wait, you can't just do that, right? But yeah, so 299,792,458 meters per second is how light is defined now. Wasn't like that when I was growing up. That has changed, right? That has changed. That is relatively a newer thing. That's perfectly fine. Gary says, if accelerated nuclear decay happened during or after Noah flood, our planet would have turned into a giant ball of radioactive plasma hotter than the corona of the sun. Yeah, they've calculated how many joules that would actually have been. If accelerated decay is a real thing, then, and all this happened during the flood and all this other stuff, the amount of energy released would have liquefied the crust of the Earth. This has been demonstrated empirically through mathematics and physics. They're aware of this. That is also part of the heat problem. Fully understood that if what they were saying was true, their amount of heat that would be released is enough to liquefy the crust of the planet. But they have a way out of that. They don't know what it is. They haven't. God maybe came down and put these big cooling fans on the Earth or something. That's maybe what they're coming up with. Yeah, God put these supernatural cooling fans on the Earth to cool down this piping hot liquefied crust. Right? I mean, they could come up with any kind of ad hoc theory. They can say God created an abominable snowman to blow cold air upon the surface of the Earth to cool it down, right? We'll call that the young Earth creationist abominable snowman theory, okay? But can they posit that? Sure. Is it logically possible? Believe it or not, yeah. Is it nomologically possible? Probably not, obviously. But, they'll posit all these weird ad hoc type things because they start with, again, the conclusion, and they can never give up their conclusion no matter what. It is solidified in their minds that the Earth is young. So if they have to posit the abominable snowman cooling theory, then they'll do that if they need to. And that's what this accelerated nuclear decay is. It's just a ad hoc theory that has no evidence for it whatsoever. The only hope that they had was the helium diffusion rates. But unfortunately, this was back in 2002, give or take, that they started on this, or 2000. They haven't made any progress on it. Once Gary and Kevin Henke and a few other people came out with all the evidence against Humphreys and the rest of them to show that all they got was wrong, all of them stopped talking about this. Humphreys has not published, or not, he never really published, but Humphreys has made no momentum on this since 2017. The last thing from Humphreys was his answers Loechelt that he gave to me that I put on the Non-Sequitur show, the Great Debate Community blog. It's still there if you want to read it, but he has never corrected anything from it. But that's the last thing. It's been 5 years since they've even touched this. They do not argue against Loechelt. I mean, they do. I mean, I guess you could say that they try to, but they'll never argue that his math is wrong. Matter of fact, Humphreys has even said, yeah, I've never said Gary's math is wrong. And I'm like, well, that if his math isn't wrong, your math is, because his math demonstrates that you're wrong. Both your math cannot be correct. And of course, Humphreys has subsequently came out and said privately that he is wrong, but he will never change his public view on that, which again, I think is dishonest. But I know Humphreys might get pissed at that, but it's just like, what else do you want to call it? I got nothing against Humphreys. I built up a rapport with him, and he hates being called dishonest, but what else do you call somebody who won't go back in public and fix things because they're afraid that it might cause somebody to lose their salvation? I mean, I understand internally what his view is on that, but at the same token, does God want people to be saved by a lie? I don't get that. I don't know why they place so much stock on their science being correct to save people, when I don't think God would give a damn one way or another whether you get the science right or wrong. I think God would want to care if you're a good person or not. I think, to me, God would be more concerned about your ethics than your understanding of very complicated topics like helium diffusion rates. That's just me, though. All right. Let me move on to the next topic. Any questions on this before I move on to the next topic? None? All right. So the next topic I want to talk about was this one right here. This is that's the human chromosome. Here we go. All right. So this basically is a refutation, I think, of Dr. Lyell's what's called asynchronous light convention. And his asynchronous convention is basically not even a scientific theory. It is basically a philosophical position. And what Jason Lyles tries to do is argue that light doesn't travel at the same speed at any vector. In other words, he's trying to say that there's anisotropy in the way light propagates. The light will travel different speeds based upon different directions. And that actually is a philosophical question that we cannot demonstrate because we cannot, as of now, measure the one-way speed of light. And that's true. Jason Lyles is correct on that. And we've known this. I mean, scientists have known this quite some time. They know that we cannot measure. And so they have to take some types of conventions. We have to say, okay, what convention do we want to use that makes the math easy and parsimonious? One sec. Give me 30 seconds here. Talk amongst yourselves. By the way, does anybody want to come in? The link is still up there. I just dropped my cover from my mic. I need a new one. This one's all messed up. I'm be going. Now I just got it rolled away. Anyways, I don't need it. I will be getting another one. Falling apart. Anyways, so there's different conventions you can use. There's the one that most people would generally use because it just makes the math really easy. It's called the Einstein's synchrony convention, and it's basically how we determine whether things are simultaneous in two events. That's called simultaneity. We have a hard time understanding what simultaneity is in relativity because it goes against our common understanding of Newtonian physics. But it's been demonstrated numerous times. We know that simultaneity means some kind of reference to understand what we mean by at the same time. The Einstein synchrony convention is basically saying that light propagates in all directions from a source in 360 degrees sphere at the speed of light. So there is no directionality preference to light speed. If it goes to the left, it goes to the right, goes up, down, whatever your coordinate system is, it's invariant. It doesn't change based upon your coordinate system. Light speed will always be light speed at any coordinate system. This is what makes relativity so interesting. When people started going, wow, this is really different from Newtonian physics, because in Newtonian physics, speed is relative to like something moving to something else. But in relativistic sense for light, light is always traveling at the speed of light from every other thing, including other things traveling at the speed of light. We don't see that in Newtonian physics, right? If something's traveling away from like the Earth at 1,000 miles an hour, then the Earth can be said to be traveling 1,000 miles an hour away from the object, right? There's a relativity thing. There's a symmetry there. You can argue that the object is moving away from the Earth, or you can do very simple Galilean transformations and make the Earth the center of the thing, or the object the center of the thing, and say the Earth is moving away from the object. Both work. Both mathematics work. If I want to argue that the Earth is the center of the solar system in a geocentric mathematical framework, it works. You could do some significant Galilean transforms, which is using matrix theory for Newtonian physics, to make the Earth the center of the solar system, and the sun goes around it in these bizarre epicycles and these other types of fantastic movements. But the math allows it. It works. Do we accept that convention? No. The convention we use is that the sun, being the bigger object, the planets going around it. That the barycenter is inside the sun or next to the sun. I think it varies a little bit, but the barycenter is pretty close to the sun. If I'm not mistaken, most of the times during the transit around the sun is actually located outside the sun. So we actually travel in a path, and the eclipse is such that we actually don't revolve around the sun. We revolve around a point just outside the sun's surface, which is an interesting fun fact. But, if we wanted to make a model where we are the center, we could do this. But the mathematics is so much more complicated. Why would you want to overcomplicate the mathematics to get the same thing? If you could do it. If I want to send a probe to the sun, like the Parker probe, we can do it with our understanding that the sun's the center of the solar system with a heavier mass, and we can send a probe there based upon relatively easy orbital mechanics. They're very difficult orbital mechanics, but comparative to what if we had made us the center, how much more difficult it would really be, because then you're dealing with these unbelievably complicated movements to try to mathematically describe them. That's just silly to overcomplicate them. That is not parsimonious. I didn't see who popped in here. Well, hi, good sir.
Hello, good sir. How are you doing? Good morning.
I am wonderful.
Evening, in your time zone and latitude. And I did send you by Patreon an email message, but it's funny you should be talking about this particular subject because I am writing notes to give a class on Introduction to Relativity.
Awesome.
And
you going back to teaching?
Yeah, I've been doing a little bit of that
I
sort
love
of thing.
That. You made my day.
It's just a senior high school physics things in a religious school that prides itself on being one of the earliest proponents of young Earth creationism. I'm not addressing young Earth creationism. I'm addressing really the notion of getting the students to ask questions.
I love that. That's great.
That's how, if I talk about how I'm being subversive, is to, and in fact, in this class, they're going to be graded on the questions they ask me.
I love that. No, that's good. I'm a firm believer in that type of a pedagogical approach to have questions.
But it needs to be scientific questions, right?
Yeah, Daniel said, by the way, Daniel says that he thinks the barycenter from the Earth is still inside the sun, but the one of Jupiter is outside, which may be. I honestly don't remember.
Sometimes the barycenter does go outside the photosphere.
For the Earth, I thought it did too. I thought it varies slightly, and so sometimes out of the year it's slightly outside, sometimes it's slightly inside the photosphere.
Particularly when Jupiter and Saturn are on the same side, they have enough mass outside
to change that barycenter,
to put the sun's barycenter of the solar system outside of
that would be the Earth is actually going around that, and that not the sun, technically speaking.
Yeah, because the Earth goes around the barycenter, but for Rock's approximation,
right, and that's why when people say the Earth goes around the sun, we to the layperson that's perfectly fine. There's no reason to be a pendant on that and basically say, oh well, it's actually outside the sun. Yes, if you want to get technical, that's fine. And I think fun facts like that are great, but it doesn't negate when we say that the Earth goes around the sun. And this is, by the way, that's a good point to bring up, Landon, that I see young Earth creationists try to do, is they'll argue things like that. They'll say, well, this scientific book says the Earth rotates around the sun or revolves around the sun. That's not true. It, revolves around the barycenter, which sometimes leaves the sun. Well, so what? I mean, people in science know this. This is not some big, whoop-de-freaking do that invalidates all of evolutionary biology or all of relativity. This is exactly what young Earth creationists try to do when they pick up on little things like this, though. And it's dishonest. It really is.
And also, as you know, in relativity, all basically, all perspectives, all frameworks are equally valid. And so you could say that the sun goes around the Earth because the sun's going around the barycenter. If you're the sun, you see Earth moving. If you're the Earth, you see the sun moving, right? And both perspectives are valid. I think when we say in terms of how the solar system works, it's a matter of what's the actual dominant center, right? Of stuff. The notion of Earth being fixed, the whole egocentric stuff, has been thrown out, centuries ago, at least by most people.
And how much more complicated would it be to make these Galilean transformations to make the Earth the center for all these probes that we send out?
Yeah, you have to get into epicycles and other wacky things. But from a
deferences or something. There's epicycles and there's something with a D too, and I don't remember what that is. Deference is that what it is? I don't remember. Somebody tell me.
But understand and say from purely relativity's perspective, for example, if you're on the moon, you see the Earth going around the moon. If you're on the Earth, you see the sun, the Earth, the moon going around Earth, right? And both perspectives are equally valid. The question really is, well, what's going on here? What is the dominant process? And really, is the Earth the center of the universe?
Right. And that's what Jason Lowes takes advantage of, though. Okay, so what he's trying to do is, by the way, I'm going to put your camera on so everybody can see you, and they don't need to see me. I'm just going to do this while I talk. What Jason Lowes does is it tries to argue, well, we can't prove the one-way speed of light. Therefore, let me give you a plausible explanation of why we see distant starlight. Right? The distant starlight problem is basically a massive problem. All right, people can see you now. Wave. Wait, and we can see Landon.
Hi.
We like putting him on camera because he's better looking than I am, and he's obviously much smarter.
I think you're I disagree, but
you are okay. You know what? But you're still you definitely are smarter. Nobody's going to argue otherwise with that. That'd be stupid. So Dr. Lyle, is putting out this argument that because we cannot see how light propagates in one direction, we have to make this convention that it travels equally in all directions. He'll argue that this distant starlight problem, that the stars that exist millions and billions of light years away, it would have taken billions and millions of years to get to us, right? And so if it takes 1 billion years to get to us, the universe has to be 1 billion years old, at least minimum. And so he argues that, I'm not even joking, this is his argument, and it's not philosophically wrong, okay? It's not even physically wrong because it's just a convention. But he's arguing that light is traveling towards the Earth geocentrically instantly, and that light going away from the Earth is traveling at half light speed, and the overall transit time is c. This works mathematically. This is actually allowed for in Einstein's equations. But Is it parsimonious? He says that that's not a refutation. I argue that parsimony is an argument against this because it is very non-parsimonious. It presents many problems, and one of which, Landon, would you agree that if light is traveling towards us instantaneously, we would be seeing these objects in space as they literally are right now, in real time?
Yeah, and you run into problems. As we use a telescope, you're effectively looking back in time from the perspective of the thing you're looking at. Is that as you see farther out into space, you have to ask the question, well, why did those things send light to us instantaneously? And does light go between two galaxies instantaneously? Which path is instantaneous and which path?
Well, he argues now that it's just the observer. I don't think he wants to promote geocentrism, right? Because the notion that light traveling to us is very geocentric, that God created Earth in a special frame of reference, that he doesn't want to have to proffer, because that's geocentrism. Right? So he'll argue that it's to any observer in the universe. So to any observer in any locality, light's traveling instantaneous to him. What he doesn't explain is how that actually is, why the universe is like that. That seems to make no sense that you giving the observer the preferred frame of reference for the speed of light rather than just being a non-preferred frame of reference. Light should be everything. It should be equal away from you as it is towards you. What is it about the observer that makes light travel towards you instantaneous, but away from you at half-light speed? Makes no sense to me.
So does the observer in the Andromeda Galaxy see light from
that's what I think you would argue.
Instantaneous and back and forth. I mean, yeah, technically it is, but I would think if you're going to engage in apologetics, just invent a universe where the deity put light in flight already.
Well, see, but he won't like that. Dr. Lyles has specifically argued that God is not a deceiver, and he wouldn't put light in transit. That's one way to get around the distant starlight model is light in transit theory. But light in transit theory, he argues, cannot be because that would make God a deceiver. One, that would mean that the light itself didn't come from the object. It would mean it came from what he called God light. It means that God has created this light in situ and then put it on its way, which doesn't make much sense. I mean, again, it goes against what's called parsimony, and it basically it's a variation of what's called the Onthalos hypothesis. That God created the Earth 2 days ago. We would never know. And philosophically speaking, that's true. You could have been not even existing yesterday. You could have came into existence today, fully formed with all your knowledge and information, along with the rest of the world. We wouldn't know. But that's just a non-falsifiable philosophical hypothesis.
And that's not a scientific question.
Correct. It's philosophy, not science.
Can answer, right?
Yeah, and Dr. Lyle's asynchronous convention is not science; it's philosophy.
But the problem is we still see processes going on in the universe that take time, and yet you sort of say, well, the light somehow magically gets to the observer, all observers instantaneously. But we don't see that in a lab when we're defining when we're defining meter, right? Because again, as you said, the meter is defined as the distance light travels in that 1/299 for a second, right? So this becomes a question of, well, how come that we don't see the instantaneous effect in one way? It is true that we've failed to come up with a rigorous way to measure light in one direction. We can come up with very good approximations for one way, but they're not. But due to relativity, you can't do it.
Yeah, well, and it's so funny. It doesn't even solve the distant starlight problem because you obviously you run into other problems too. Like you said, we know that certain processes take time. When we look back in the universe, right? When we look at what the James Webb Telescope is sending us, we're seeing galaxies as they were when they initially came around. We're seeing them to be younger. If Jason Lyles was correct, we would expect at least homogeny, or what he argues. We argue the further you look back, the older it should seem. But we are seeing the opposite. We're seeing that younger things exist way out there because we're seeing them as they were billions of years ago, not as they are now. And we also, like Lana pointed out, we know the processes of stellar mechanics, and we know that the certain older type of galaxies should have different spectral analysis of elements than younger ones. We should understand that they're going to be higher in certain elements, in iron and heavier elements, rather than newer ones that are, going to be helium and hydrogen. So, because it takes time for heavier elements like nickel and iron to be produced in stars. We also know that uranium is produced in supernova, which takes millions and billions of years to actually come about.
And we know that plutonium can be done in certain types of supernovae or neutron star collisions, but we don't see the universe full of plutonium because the decay rate doesn't allow it to have much left over.
And accelerated decay would change those decay rates, which is a problem.
Yeah,
fusion wouldn't work if decay rates weren't exactly what they were. Fusion wouldn't. Sun would not work.
Yeah, and a lot of stuff would get messed up. But even to say, C, people say the speed of light in a vacuum is really the speed of causality. Light happens to be obeying that when you look at the space-time diagram.
Yeah, it's fun. I think it's baked in. The speed of light to me is baked into the universe. Is reality. We don't know why this goes into what's people can say simulation theory, but the reality is it is a very hard physical baked-in constant that Einstein recognized.
And you get to approximating C through Maxwell's equations. That's one of the
Maxwell.
led
Yeah,
Einstein.
Well, Maxwell
to,
came up with nearly the correct answer to the speed of light just by using his understanding of electromagnetic radiation.
Yeah, and again, as Einstein was a super fan of Maxwell, right? Who is a person that is some people just don't appreciate, but he is one of the giants in the scientific world.
Oh, absolutely.
And did just extraordinarily bang on stuff. And so if light didn't do the C stuff, some of the Maxwell equation problem, Maxwell equations has a problem there.
Yeah.
With that again. But
I don't know how much it would affect the first one, maybe two. I don't remember. It's the third and fourth Maxwell equation. I'm a little lost, and I'll admit that they're very complicated. But the first one is pretty simple. But anyways, if you look on the screen, I don't know if you look at the outside still, but I'm showing supernova set 1987A, which happened.
Oh, yeah, one of my favorite supernovas.
Yeah, it's 30. What was it? 30 years ago.
1987A was the first supernova detected in 1987. In fact, I was on the internet back at that time. I saw the message come from the observer in South America.
So that was about 36 years ago, and that's why because I graduated.
I saw the message come over saying of reporting the sighting of supernovae, and I got on a phone and called my friend in Australia and said, "Hey, I'm coming for dinner." And I had one of my employment rules was if there's ever a visual supernova, I get to go instantaneously to the spot as much quick as possible to the spot of the world to actually observe it. And so I got on. I always had in my trunk my passport, enough cash, and I just drove straight to the airport and said, "Put me on the next plane to Australia." Landed and was there at the observatory like 18 hours after the discovery. And I watched that star brighten. I watched it change color. I watched it go up the supernova curve and measured the stuff because this was a chance of a lifetime.
All right, so let me ask you. So Dr. Lai would have argued that this explosion literally happened 36 years ago, not 186,000. Okay, so this 168. So this star, for people who don't know, I believe was a blue giant. I haven't looked at it in a while, but if I remember, it was a blue giant.
Blue straggler. Yeah.
Okay, that went supernova back in 1980, and this object had light coming out from it, and it produced these bubbles, these north and south bubbles that came out of it, which light reflective off of. And a couple years later, we can see the reflection of light from the initial explosion from these gas bubbles that came out. By using what's called triangulation, we could determine that this star is 186,000 light years away. Young Earth creationists don't deny this. They recognize that the math is correct. They will say, yes, using this method is perfectly fine. We know that that this object is 168,000 light years from us, give or take, which means, according to basic relativity, it took 168,000 years for that object's light to reach us, which implies it happened 168,000 years ago with respect to us, correct?
Yeah, the universe was a scale where it took light 100,000 years to travel a distance. From our perspective, the now happened in 1987. That's when we saw the supernova, right?
But when the event actually did happen.
Well, yeah, but that's a question of what do you mean by when it did, right?
Yeah.
Remember,
that's what I'm saying.
No
with respect
perspective
to us.
is authority, right?
Right. With respect to us, it was 168,000 years ago.
It took light 186,000 years to reach us.
Yes, that's what I'm saying. We could, but we can look back. We can go. Okay, since we know that, we know how long ago it was when it actually happened. If we wanted to go, if we actually wanted to see this event, we would have to literally time travel from our position 168,000 years, right?
But when you do that, you have to do the space-time coordinate transformation. That's another rule of relativity.
Yeah, right? the Galilean transforms.
You can't just so from our proper time versus its proper time.
Or Lorentzian information speed of light.
Light took 106,000 years approximately, given the current scale of the universe, to get here. That's what we mean by the distance.
Right. So if that's the case, that would put the lower level limit of the age of the Earth to be at bare minimum, 168,000 years. That's just how it would be. Now, clearly we know the universe is older, but just by that one observation, we know the minimum age of the Earth, of the universe must be, at the very minimum, 168,000 years. Now, what Dr. Lyles is arguing is that light from that object reached us instantaneously. But the problem is like I said, we saw light reflect off the bubble, which also reached us instantaneously.
Yeah.
So how would that work if we see light traveling from it to the star, the bubble? We know that took time to form. We know that by triangulation, this object is that distance.
And prior to that star going supernova, it had a lot of ejections, and we can see, I just say, the light bouncing off of those shells. In fact, we still see light echoes to this day, and we can measure the size of those echoes by seeing the light bounce back to back and come back to us again. So we see these echoes happening over and over again, which is one of the ways. But also there are Cepheid variables in the large, the small dimensional cloud, and there's other objects there that help refine and help validate.
There's all the consilience there, right? Even the Cepheid variables have a consilience.
Yeah.
There's nothing in science that puts the age of the universe anything less than around 4.5 billion years. There's just nothing. It doesn't exist.
And I say, in terms of the date of the Big Bang, we talk about as being approximately 13.8 billion years, plus or minus 140 million years, because what we say is the Big Bang flash, the universe was at the size when the Big Bang flash was emitted about 13.8 billion years ago. It took light that many years to reach us from the Big Bang flash right now. Now, obviously, the distance is different now, but that's what we mean. Astronomers get kind of sloppy sometimes when we say, this is 13.8 billion light years away. What we really say is the universe was a scale such that it took light from there 13.8 billion years to reach us.
Yep. Let me ask you this, though. So this blue giant that went supernova, does Dr. Lau have a theory of how a star can be made? And whatever, let's say it's 7,000 years old. It was made 7,000 years ago. Does he have a theory? And the answer is no, by the way. But does he have a theory that how a star can be created and explain 7,000 years later that this star literally just exploded only 36 years ago, according to his theory?
Because just the amount of time for it to blow off its shells, right, as it goes through the various phases of hydrogen fusion, helium fusion, carbon, silicon,
carbon nitrogen oxygen cycle.
But the various phases of the carbon nitrogen oxygen to the neon, silicon, and eventually iron, and you can see the ejecta from the star going through those phases because the light's bouncing off.
Yeah, all that would have to happen within 7,000 years.
Yes, and the star has to form. And that was a massive star that had to form, and you can't get that much hydrogen to come together very effectively to begin even to have fusion.
Yeah, he has to argue that the star was created in existence and it didn't have any process to form, and that there's some kind of stellar theory that can allow for this blue giant to shed off these shells of elements that take a very long time to start producing. You just don't jump from hydrogen and helium all the way up to silicon and nickel. It takes this intermediate steps, and every time it does, it's harder to keep the pressure of the star in equilibrium, because basically a star is held up by you have two pressures. You have gravity, you have gamma pressure. So you have all these gamma pressures that's coming out of this massive pressure coming out of the star from the fusion. We're not going to get the technical stuff, but just basically you have an outward force and you have gravity as an inward force, and these two forces are at odds with each other, and there's a balancing act to be had. And when you start to go from one fusion isotope to another, or element to another, there's less energy coming out of it. So there's a lot of energy packed into hydrogen and helium. You can get a lot of fusion out of that.
Yes.
But as you start getting higher on the periodic chart, and you start doing things like carbon, nitrogen, oxygen, and even higher than that, silicon and nickel, the amount of energy you get out is way less, which means the dominant force is going to be more of gravity. Yeah. So the gamma pressure is going to be less when you start using these other types of elements. And so this is why the star eventually fails. Eventually reach a point on the field curve or the fission curve or fusion curve.
Exactly.
That you're not getting anything out of it. You can't fuse.
And the reaction goes from endothermic to exothermic by the time you hit iron.
Yeah, by iron 50 or whatever, you have to put energy into the system to get energy. You have to. Well, you do it with fusion, but for fission, you have to put more energy in than you're getting out. So after a certain point on iron, you have to put more energy than you're getting out, and that's not stable.
Yeah, and as you know, in fission, is large nuclei breaking apart, you get energy. And in fusion, you have small nuclei coming together, and the two curves kind of meet at the balance point.
So how come Lyell doesn't have any scientific papers on how any of this would actually work scientifically?
And so as the star goes through this process, right? Because when the star is let's say if it uses up most of its hydrogen, and helium and has to go to 3 heliums of carbon, the star begins to collapse. The temperature in the core rises, the pressure rises, and now you have helium fusing to produce carbon, and that's a much more energetic. That goes at a faster rate, and so it blows off the edge of the star as the new core processes start,
right.
And that's why we see the light echoes of that shell, right? And not only that, the shell that it hits has the right material according to nuclear synthesis, right? It's not just a random bit of.
We know that it contains, let's say, it has oxygen in it. We know it contains silicon. We can take a spectrography of it, spectrogram of it, and say, okay,
because
what are elements
the light goes through the front of the shell as well. I mean, we see the imprint,
so we know
and we
what
also see
chemical
the
makeup
Doppler
is.
shift of the whole thing and all this stuff. So, but I don't understand why, if he says, "Oh, God's not a deceiver," so God didn't put light in.
But he'll deceive people this way.
but he'll say God created this star in
fully
formed.
Formed.
Collapse.
Yeah, because he'll argue that he created Adam fully formed and in maturity. Therefore, he created the stars with maturity. Therefore, he doesn't need any kind of actual scientific explanation on solar modeling of how these stars come into being, which seems to be odd because we know all the way back from Hubble, when we look at these stellar nurseries, stars are still being produced. This was, by the way, fun fact. Landon's old enough to remember this. But you guys, I don't know. But back in our day, creationists would actually argue no new stars are being produced.
Yeah.
That was an actual argument the creationists had until they started taking images of stars, new stars being made.
And it's like, well, what about these stars we observe that they're in the process of being, as you say, bored, switching on.
Yep.
But it's a slow process that we
But that requires
happening.
a scientific model. Young Earth creationists have to accept old Earth models in order to explain star formation. And yet, they think that God created these things already preformed with no model. That just
or not, if God's not a deceiver and you're just mistaken or whatever. But it's the big scientific problem I think they have is they start with a conclusion,
right,
and then they rationalize everything from that conclusion. That's this presuppositional stuff is tantamount, I think, to intellectual suicide.
I agree. And matter of fact, again, it's just it's a sophistry because again, this is the way I would describe Jason Lyell's anesotropic synchrony convention. It is basically saying, I'm going to argue the Earth is the center of the universe. And you know what? I could argue that, and I wouldn't be wrong if I use geocentric modeling, which is perfectly fine. That mathematics does work. I can easily use Galilean transforms to put the Earth at the very center of the universe, and there's nothing mathematically wrong with that. However, it makes the math extremely, extremely complicated, but it would work. And so if I said I'm the center of the universe, that's true, but so's land in the center of the universe, so's you. Any point you pick is the center of the universe. All points are the center of the universe. So what Lyell is basically doing is using a philosophical argument is to say that, look, we cannot measure the one-way speed of light. Therefore, you should at least think it's plausible that light could travel instantaneous to me. And it's funny because to light does travel instantaneous. A photon that's being produced from supernova 1987A, if it's produced right now in that star, or it should be 168,000 years ago in that star, and it hits us right now, the travel time to the photon is instantaneous. It doesn't recognize any travel time, which is true. right? But again, this is why
Yes.
we have relativity, because again, you have to go by the observer, and there's no preferred frame of reference. What I think Lyle is doing is just making a simple philosophical argument that, yeah, you mathematically can make this work, and you can make light speed any value you want, so long as the net light speed is the same,
Yeah.
is c.
Yeah.
The maths
Yeah.
work. That's fine, but just because maths work doesn't mean it's the most parsimonious approach to something. That's my argument.
Yes, and that's the same sort of thing in relativity, where you can argue, again, it's like saying you're driving down the road in a car. From one perspective, you're remaining still, and the rest of the earth is going backwards.
Right.
Right. And that frame of reference is valid. It doesn't mean that's what's happening.
Right. Somebody just recently was talking about football, and they're saying something like, how the football trajectory went from the catcher's hands to the quarterback's hands, and you could model it that way. You could actually say the catcher threw the ball to the receiver threw the ball to the quarterback.
It's useful, right?
Yep.
That's that kind of thing. But the one-way light measurement, while we can't do it exactly, there's a whole big thing about what slow clock transport synchronization, where you try to put a bound on the thing. So you need to be careful, because it's a little, I think they play this little word game where, because we don't have an exact closed loop one-way transport, because it is difficulty of synchronizing clocks, we don't know what it is.
Right.
But in fact, we can do we can take two clocks and slowly move them forward. We can put a bound on the error, and
it'll give us an idea. But there's still problem, obviously, with the slow transport.
Yes,
but
that's because it's an error. But
right,
remember,
right, it's an error.
In science, a scientific measurement should always come with an error bar.
Yeah, but the young creationists aren't going to accept that. They deal in absolutes, right?
and that's and then they also deal with people who are the Pope or the religious dogma generators, right? So that's why for example, they keep attacking Darwin for stuff.
We know that we don't. Darwinism is how old. We don't. Biology is not preaching Darwinism. And by the way, this is why I don't have these long conversations with people on YouTube comment sections, because these are complicated topics, and you're not going to get it out in just a little bit of a.
Yeah, you can't.
Right.
You can't send short messages. But I think what you can do is what you're doing, Steve, is ask the question: well, how do we know what we know? Mm-hmm. What's the philosophical method for determining, trying to establish knowledge? What's the criteria we have for establishing knowledge? And then what have we done to amplify that? That's something that I think is important. Yelling at young creationism or poking fun of it is a entertainment, but I think it's more valuable what you're doing, which is saying, well, how do we know what is, and what's the basis on which we have knowledge?
Yeah, no, absolutely. Matter of fact, this actually goes into epistemology of, how do we know something? What makes us, how can we say what we actually mean by what we know?
Yeah. Yeah. And it's a thing as well. Again, it's like in mathematics, there's wild ass guesses, and there's hypotheses. If I'm going to have an hypothesis about something, I need to give you a really solid heuristic argument that needs to survive direct scrutiny and lead you hopefully towards a proof.
Yeah, I would recommend anybody. There's a great paper, which is the first half is pretty easy to read. After that, give up all hope. But it's by a guy named Ernest Sosa, a very brilliant epistemologist. He wrote a paper a long time ago called "The Raft and the Pyramid," and he talks about what's called methodism versus particularism, and it's very, very interesting of how it relates to science. About what do we need to ask first? Do we ask how do we know something, or what do we know? And it's really is a fundamental question in philosophy. Do we start with how do we know something? What does it mean to know something, or do we start with what we know and then derive how we know that? There's a very fundamental different approach between methodism and particularism in science, even about, do we start with what we know to be the case and then extrapolate and infer and do inductive arguments, or do we have to say what is it knowledge even mean, and then go on to, based upon how do we know something, to what is it that we actually think we know?
So I would value your response to this, which is oftentimes in science, when someone asks why, does light travel that fast. They're really asking, what are the circumstances?
Yeah.
What is the cause of?
Yeah.
If you say, why does something fall? You're really saying, what's the effect of this? And by the way, this thing here is not because there's a force called gravity.
Yeah, I have younger creationists asking me for an accounting of this. They're like, well, how do you account for this? And I'm like, these are technical questions. I'm happy to answer, but I want to answer where people can come back and watch later. I don't want to spend a lot of time diving into these topics on a YouTube comment section that one or two people are going to read. It's just not worth my time or anybody else's.
Yeah.
You know?
So did you agree with that notion that oftentimes in science, when you ask why, you're really asking what is the cause?
Yeah, you're asking for, okay, so there's a different, when we ask why, there's a different in what we're asking for, whether we're asking for a metaphysical cause, a physical cause. If I say, hey, why did you throw me the ball? I could answer, well, Landon wanted to throw me a ball, right? Or why did he throw me the ball? Well, he moved his hand in such a trajectory that imparted, momentum to the ball. The ball took a parabolic trajectory and came to my hand. There's a lot of ways to answer that question about what you mean by why. It's just asking for an accounting. But if you ask how did the ball get from you to me, just answering that as, well, Landon wanted to throw it to me is not a sufficient answer. It's not really answering the metaphysical question of how did the ball actually leave your hand and get to mine. That requires physics, right?
Yes.
And so that's what we mean by when we're asking those types of questions.
Yeah, and that's often so kind of in class.
Now, if you ask, why does the physics work that way? That's a whole different metaphysical question.
Yeah, and this is part of really saying, what's the cause of this going from here to here, right?
Yeah.
And by the way, the answer is not gravity, because force of gravity, because gravity is not a force. It's because of curvature of space-time.
Yeah, I had explained that.
And that's a difficulty I got to try to help these students see is that this relativity stuff is not Buck Rogers Star Trek type exotic stuff. It happens right here, right now.
Do you know Von Helton? Do you know that name?
Yes.
You know who he is? On YouTube?
Yes, and he's a YouTuber on there.
He's a flat earther YouTuber, yeah.
Yeah.
And he's crazy. He has a lot of fantastic stories. But I was just in a hangout with him the other day on G-Man's channel and trying to explain to him that gravity is not a force in relativity. It is a Newtonian physics. But that's a concept that if you have no understanding of physics, you're just not going to wrap your head around. And he was saying, well, they see how they change things, and they argued back in my day that gravity was caused by molten iron that's moving around in the earth. I go, no, you're talking about the magnetic field. And he's like, well, is a magnetic field gravity? I'm like, I give up hope on humanity at this point.
No.
It was comically bad. He was like, no, magnetic field. No, I'm not talking about magnetic field. I'm talking about gravity. So he pulls up a paper, and the paper says, something like, how the iron density and relationship to magnetic flux. It was right there in black and white. Even his own paper said magnetic flux. And he's like, well, magnetic flux means gravity. No, it doesn't. No.
Yeah. So Feynman argued that relativity needs to be taught early. That's a mistake to introduce people to Newtonian mechanics purely. Get them locked into this FG 1 and 2 or squared stuff, and then in advanced graduate school mention relativity.
It should be in high school. All that should be taught in high school level.
And so that's why he spent time, because he said, I want to refine my ability to explain relativity, and you seem like a smart kid, so I want you to come back up to Lawrence Berkeley, and I'm going to teach you relativity, right? And he basically spent several days dumping into my brain general and special relativity, giving me problems to go back and forth. Why? Because he wanted to understand it better, and he felt he couldn't if he couldn't explain it to somebody. Right? And that was his part of his how he acquired knowledge, was the ability to explain it to somebody and then answer the questions.
Yeah, so it's a shame. Richard Feynman was one of the greatest, I think, teachers of all time.
Extraordinary person, and it's fun to be around too. He was quite a.
I'm gonna move. I'm gonna go to the last part of this. Okay. It's been a while since we've dived into this, so I don't know how fresh you are on it, but it's going to be on human chromosome number 2, because this is going to be coming up. I have a biologist that's going to be coming on to discuss this topic. He is a evolutionary biologist. All these people are like, can you give evidence for evolution? And here's the thing: the younger creationists you find in these younger groups and these YouTube channels, most of them, in my experience, have had no education in these topics whatsoever. They're just taking terms, they're running with it, they're not understanding the concepts, so they don't even know what they're asking sometimes. Like that one guy asking me, have I observed a priori knowledge? It's just fundamentally bizarre to ask such a thing. So I don't waste my time with those types of things. But if you want to come on to a show like this and have a discussion, I'll bring the experts, because I'm not an expert on biology. I'm certain, I'm not any kind of expert, but even Landon will admit he's not an expert on biology.
No,
computer science,
I rely on other people, yes.
Yeah.
I'm amazed at what biology is able to do, given how extraordinarily complex all that stuff, let alone cells and so forth. But I understand they have very rigorous methods of doing what they're doing, and I'm just impressed at what they're able to achieve.
Absolutely. All right, so what this chromosome fusion did is that in humans, we have a certain amount of chromosomes. Our diploid number is considered to be what's called 46. It means we have 23 pairs of chromosomes. And all other members of Hominidae or Hominidae, however you want to pronounce it, I say Hominidae, but I've had people tell me it's Hominidae. I don't particularly care. Homoidea, I've heard that as well. I mean, I've heard various people pronounce these terms. It's Latin. I don't care how you pronounce it. If I want to say Homoidea, I like Homoidea. Do you know how actually it's pronounced for great apes? I don't know if there's if there's a single, but I've heard it pronounced multiple different ways, and people that have accents will say things differently. So, but whatever.
The person I knew had a very Swiss accent, and so I'm not sure.
That's what exactly
what I was hearing or what they were saying.
Right, exactly. And it's Latin, so we don't even know how Paul originally said it. But let's say it's Hominidae or Hominidae, Homoidea. But we all members of great apes have 48 chromosomes or 24 pairs. And so the creationist argument for a long time growing up in the 70s and 80s, they were like, oh, we're not apes. We're not related to apes. But of course, evidence said otherwise. And one of the evidences they had back in the 80s, not to the extent that they do now because they've come a long way, but originally they recognized that there were some bandings on these chromosomes, the pantoglyptide 12 and pantoglyptide 13 chromosome. And they recognized that human chromosome 2 looks almost exactly like chimpanzee chromosomes that have been fused together. Now, again, this is not a proof unto itself. No, not saying that it is, but it was something that they took note in the 80s and said, look, why do our genes almost exactly correspond to chimpanzees if we're not related? And if we are related, how do we explain why chimps still have 48 chromosomes and we have 46? How do we explain that? Creationists are like, oh, that disproves evolution. And creationists were like, oh, there's no evidence that we have relationship because this can't be, we have different diploid number. And of course, biologists said, no, wait, we do have the evidence. Let us show you. And so this is, a very basic, if you look on the outside, Landon, the outside is that there was two ancestral chromosomes that fused together, and that gave us one chromosome that have two centromeres. One that's an active centromere, which if you remember your biology out there, that's where the spindles come together and it will come and have mitosis and split apart. And then they have what's called a cryptic or inactive centromere, which shouldn't exist anywhere in a chromosome unless there was a fusion. Unless at some point that was an active centromere. And lo and behold, on human chromosome number 2, what do we find? Not just almost exactly the same sequence and genes. We find that it does have this inactive centromere, which they didn't know for a fact existed in the 80s, but we do now because they've actually have transcribed it. They've actually shown what it actually is. So this has been a big thing on the younger creationist movement to say that this is not an actual fusion. Dr. Who was it? Tompkins, who is a botanist, biologist. He argues there's an active gene there called the DDX11L2 gene. But the problem is that when people started asking him for evidence of any transcriptions of this particular gene, he provided none. He couldn't find a single solitary transcription that was not spurious, or just, it doesn't produce any kind of functional protein or any kind of RNA. It doesn't produce anything of any functionality. It is a well-known pseudogene because it's of all expense. You guys could say it's a dead gene.
Okay? Yeah, because if there's no protein or RNA expression, it is effective. It's what we call basically a dormant or dead.
Yeah. Yeah, exactly. I mean, sure,
inert part of the genes.
But young creationists will say, well, we know there are some non-functional genes that produce non-coding proteins and that produce things like messenger RNA and RNA fragments and things of that nature. Sure. So what? That's not what we mean by it. That's never been what they mean by a functional gene. They mean by a functional gene is that under what's called the central dogma of biology, it produces some kind of protein. That's what it means. For a gene to be functional, it produces protein.
That's the function of a gene.
That's the function of a gene. Now, could it have other functions? Sure. There's certain genes that produce our messenger RNA and just types of small snippet type DNA, small what they call them, short RNA strands. But so what? You could produce. By the way, you could produce a peptide. Peptide isn't a protein. A protein is a long, structured form of these amino acids that have come together to produce something that they have a functionality to. For example, collagen. Its function is to provide structure. It's a protein. Certain other types of proteins have enzymatic functions. They lower the activation of things, right? And so when these proteins have these different types of functions, the gene itself, for functionality, this means that a protein was produced. And so Tompkins will argue, well, it produces this other stuff randomly and spuriously, whatever, but that's irrelevant. It's not an active gene that produces any kind of protein. And what's even more interesting, if you're watching the outside, is that they've recently, not too long ago, went into this region and analyzed what it is for the nucleotide components. I don't know if you remember off the top of your head, but the motif for a telomere is TTA-GGG. Mm-hmm. Okay. That is just for humans, by the way. There other animals have other types of things for the telomeres. But what we do is when we look at a chromosome, again, I'm not a biologist, but this is going back from my days on this topic. A telomere is what's at the end of a chromosome to prevent this very thing, this telomeric fusion.
Yeah. And it's basically the stop it's the stop sequence or start sequence for that stuff, as I understand.
Yeah, it's the end cap. It's an end cap on the centromere. It's basically when I showed the other diagram here.
And it is something also that will sort of limit the longevity of a.
Yeah, about from what I understand, the Hayflick limit is about 50 times each cell can replicate, because each time it's replicating, the chromosomes are splitting. It's making the telomere shorter.
Yeah.
And so a cell is eventually going to die. But it can it really can only split 50 times for the Hayflick limit. But if you look at the blue,
although on the other hand, here that the NASA twin experiment where the guy was up in the space station and his twin was down, his action telomeres actually, when they came back, they discovered they actually lengthened. Yeah. There's some process.
Yes.
I mean, the other things we don't understand, and that's one of the things that says is that it's a limiting factor, but it doesn't seem to be an absolute.
But we might be able to change senescence, how these things work when it comes to senescence one day. We may be able to do that by making the telomeres longer. That actually is active study in that.
Oh yes.
So, but if you look at the blue bands on this, you'll see that the telomeres are at the ends of the chromosomes. So the question is why do we have human chromosome 2 where the centromeres have 2 of them and you have the telomeres in the middle of the gene, or in the middle of the chromosome? That should not exist. The only way you can get 2 telomeres like that in the center of a gene in human chromosome number 2 is if they fuse together.
Yep, they can together. Yep.
Now the younger creationists argue, well, it's not a fusion. It's just degradation of spurious motifs. Well, that's complete nonsense. And if you actually look at it as to why, here it shows the motif TTA-GGG repeated about 16 or 17 pristine motifs of this. You're not going to find this motif anywhere outside of the telomeric or even the subtelomeric regions. You shouldn't find this motif in any real regularity. You're not going to find 16 or 17 of these motifs in anywhere other than the telomeric or subtelomeric regions. So we know this was a telomere.
Yes. And by the way, Averil's also correct that effect when he came back down to Earth was reversed. It went away. So these telomeres are much more complex than simply just you run out of it, you die. And gravity seems to be have an odd effect, or the environment of space, microgravity, or something like that. But again, these telomeres are not these immutable things in the end you can't have interactions, and you just showed me, I think, good evidence of such interaction of two joining together.
Yep. Yeah, because again, there's no other reason why you would have telomeres like that. And it explains it. It explains why we have one less chromosome. Because if this was a event where the two chromosomes came together and you lost one for the haploid number, then of course for the diploid number you're going to have, two less. You're going to have 46. And so this is why we have 46, pair total genes. It's pair. You have 23 pairs, and then that's your haploid number, and then you double that, your diploid number. So,
but it's I think it's extraordinary what they've been able to do with this genetic stuff, and then also the evolutionary biology that they can do to essentially start working backwards in time in terms of understanding your relationships. It is an extraordinary bit of science that I'm quite impressed with.
Yeah, well, I'm fascinated by how biologists do this stuff. I really am. It's just mind-blowing that they recognize visually that there was a strong similarity between human chromosome number 2 and chimpanzee pantoglodyte 12 and 13, but it's just a visual confirmation, right? It wasn't until they actually went in and said, oh, look, we have now found the actual fusion site. This is it, highlighted in red, where you have, yes. And if you notice, the motifs reverse direction after the red. That's very telling. It reverses directions because they were fused together. Yes, yeah. That's the fusion site between, because they actually change there. Let me see here, something here.
That's impressive.
I pulled the source up, but I can't seem to find it now. But that's okay. But anyways, this is like a smoking gun. This is the smoking gun that creationists keep asking for, but then they don't want to ever talk about because they'll just bring up Tompkins' work. But Tompkins has been futed ad nauseum. Matter of fact, creationists don't realize that Tompkins' first paper that he tried to put out was arguing that humans and chimpanzees are only 70% alike DNA-wise. And this was touted by creationists. Oh, look, we've demonstrated we're not related. We're 70% different. Evolutionists lie. And then he was pointed out by Ruhiv, actually, had discovered this, that Lyle had used... No, I'm sorry. I don't think he pointed this out. I think other people pointed out to him. There was another thing that we were pointing out. But it was pointed out to Tompkins that the BLAST program he used, which is a program to sequence these things, had a known bug in it. And that bug was created this 70% number, and he recognized this. He did realize, okay, I'm using a variation or a program of BLAST that has this error in it that we know of. I need to get the most updated version. So when he reran this with the updated version, it came out to be like 99%, right? But of course, he couldn't have this. So he manipulated this, and he used what's called the ungap parameter on BLAST. And he put every indel that's normally counted as 1, he counted every nucleotide difference in the indel, which is not how any rational biologist would ever do a comparative analysis, because an indel is a single event. It is one mutation, even though it may contain multiple nucleotide differences. It is still considered just be one difference. And he just manipulated these numbers to get to more of an 84% or something, if I remember correctly, in the 80s, which still is way wrong. But it was clear that he was manipulating the data to try to fool people. Because again, with creationists, end justify the means. But they have never refuted that this right here is not an actual telomeric fusion. They'll throw all this nonsense out there, but there's no paper out there they've ever put that denies this, that can show it to be wrong. Not one.
Yeah.
They just throw out stuff on their web pages saying, oh, well, it's not a fusion. And then they get into some real technical stuff that you needed a PhD to understand. But then the PhDs who do understand come out and say, no, you're wrong.
Yeah. But this is a problem you run into when you try to do this rationally. Till you say, I have the truth. This is a dogma. I have the truth. And I'm going to try to bend reality to conform to something I want. And that's about as unscientific as you can get. In a manner of speaking.
Yeah.
And by the way, April 24andMe domain has already been taken. So if you're trying to set up that service for your chimpanzee relatives, someone only has that domain. So
yeah. Yeah, I don't. Benjamin's talking about the specific genes on the chromosome number 2. There are sites out there that'll tell you all the genes in that chromosome, whatever proteins they do produce. They are out there. I haven't looked at that specifically in quite some time. What genes are on there? I don't know if I don't know if there's an HLL complex on chromosome number 2. I think there was on 6, but that I've looked at before, but I haven't seen anything on 2. But it may be, again, that's too technical for me.
Wow.
Yeah, but I do know there is a site you can go to that will list the bigger genes out there and what they do, their functionality on the chromosome, and also they have the same function on the pan-troglodyte one, from what I understand. And this shows the image I have up now shows that as well. If you look at the 2 genes from chimpanzees, which is the middle and the bottom one, when you look at the top one, which is the human one, you can see they're the same genes. You can see. You don't have to have a degree. And again, I hate pulling this, you can see this, because young Earth creationists do this all the time. Well, it looks like this, and it's completely not. But in this particular case, not only does it look like it, right, but you can actually go in and see that the genes have the same function. So it is the same gene.
Yeah. And as I understand, when they do gene comparisons, you don't have to. You're not looking for an exact perfect match, because there are
There's of course, there's going to be differences. There's going to be degradation.
But you talk about saying that the degree of correlation, it tells you that they're essentially.
Yeah, you can see where the telomeres overlap. You can see exactly where the telomeres have fused together. And there is some loss of data there. There is some bit loss. It's very small from what I understand. But so what? The other genes are still fully functional. It wasn't some kind of catastrophic event where the organism would die. If you have a Robertsonian translocation, which is called, because human chromosome 2 was one of the chromosomes that you can have a Robertsonian translocation. So as long as you have all the genes there, all the information that's relevant to protein production, the organism survives. It doesn't care. It's just located. It'd be like me explaining it this way. If you have a software that's dependent upon a DLL on your hard drive, it doesn't care where on the hard drive that DLL is, as long as it has a link to get to it.
I mean, or say in Unix, if you have essentially a shared library, you have a library shorts path.
As long as you know where it's at, you can find it, right? Yeah. Does it care where on the hard drive that is?
I mean, there's a process by which it's finding it, but also, I think be careful, because genes themselves, as you know, are not. It's not like a computer language.
No, there's a lot of complexities in gene linkage.
And it's not, because computers are some ways relatively simple machines compared with what's going on in that
much
set.
More complicated here. Yeah. But it's just a simple analogy. The gene has to be located somewhere on that chromosome.
Exactly.
Where it's located doesn't matter, as long as it knows.
As long as there's a process to
link to it,
to activate it,
yes,
and then to then have it function with its
and that is a complicated process, not going to deny. And this is where young Earth creationists would go, well, that means intelligent design. No, that's completely a thrown out hypothesis to that. So they just throw it out there. Well, it has to be intelligence. There's nothing that's indicating any kind of intelligence. Sure, it's complicated, but
if you're having your bingo card, complexity is what are the free spots you often get in playing young Earth creationist bingo.
Is complexity, because it's always going to be
complexity, big numbers, machine, that sort of stuff. Yeah, it's one of the common things.
Yeah, and that's one of the reasons why I personally do believe that intelligence design is just young Earth creationism packaged differently.
Oh yes, it's attempt. I believe part of its origin of that thing was an attempt to try and work a way around a Supreme Court ruling.
Yeah, exactly. It was. That's exactly what it was. That was. It was the court was. It was a case called. Oh my goodness. It's on the tip of my toe, and I should know this. Kitzmiller versus Dover. No, I didn't look it up. I had to think about it. But Kitzmiller versus Dover, and I also I've been talking to Casey Luskin, who's the lawyer that did some work on that particular case. He works for the Discovery Institute. He's a real nice guy, actually. He's going to come on eventually. I just haven't gotten back to him yet. I told him, after the first of the year kind of stuff. But he wants to debate somebody of sufficient caliber, and that's going to be very hard to find. Anybody who wants to debate him on that, not because they're not sufficient caliber, is because, one, you not just have to know the biology, which a lot of people do. They have to understand the arguments of the creationists, and a lot of them don't waste their time with it, and I don't blame them.
Yes.
So I think I might have one. Like I said, I have a biologist coming in to talk about this particular topic and other topics on the Non-Sequitur show. His name's Zach Hancock. I don't know what his understanding of intelligent design is, if he'd be up for that, but I'll talk to him on the next day or so. But anyway,
like I say, my preference is to focus on how do we know what we know, and what's the methods and what are the processes involved. But certainly there are people who are really good at refuting. I mean, people like Dr. Dino or other folks out there are doing a job of refuting some of this stuff, and encourage you to seek out resources for people.
I like Gutzak Gibbons. I think she is probably the most formidable. I want to call her lay evolutionist, but she's not really. I mean, she has credentials, but she's still in her studies. But I mean, for somebody, at the undergraduate, is she have a master's degree? I don't remember. Or is she working on her master's? Is she at the undergraduate level?
I thought it was at the undergraduate level, but I could be wrong.
It doesn't matter because her understanding is way beyond the undergraduate level. Her understanding is just par none. I mean, there's nobody that competes with her, I think, as far as her ability to understand and relate some of these topics effectively to the lay person. And I think what she does is just amazing. Her and Apologia. But that's what I'm saying is the young earth creationists, they don't get into any of the academics. They don't take any of these courses. And when they do, they just butcher them to no end, and they start using terms so atypically. It's unreal. And then I have these guys quote mining things to me. Well, this biologist says this. I'm like, irrelevant. I'm only going to go by what's in peer review papers. What they say on their own time, I don't care. What they say in their own books, I don't care. That's irrelevant because that's their personal opinion, but that's not how science works. I'm going to go by what's in the literature, the academic literature, because that's the body of evidence that we evaluate.
And also the strength of those peer reviews.
Oh, Erica's working on her PhD. Okay, she's finished her master's. She's working on her PhD. Okay, I didn't know she was a pre-doc or not, but yeah, I mean, she's going to easily get her PhD. I mean,
and I think it. No but question. Again, you also look at the strength of those papers, because you also look at the citation of it. Not that there's an argument of what's popular in paper citation, but that can help you understand how the claims of a paper have been tested by its ability to be cited.
Yeah.
And
the
back
paper,
and forth.
The paper on human chromosome number 2, which I've read numerous times, not saying that I fully understand it, I don't, but I have read it and tried to parse it out. But there are certain parts in that paper that are pretty easy to understand. Mm-hmm. That paper has not been refuted by young earth creationists. They just say it cannot be. That's not an argument. There has been nothing from Answers in Genesis or ICR or creation.com outside of their own domains that has any evidence that any of this is wrong. Dr. Tompkins tried to refute this. He comically made the argument that there was a transcribed gene called the DDX211 DDX11L2 gene. But the problem with that is that, again, when you ask him, where is this transcribed? Where is any database that has any kind of level of active transcription of this particular gene, he falters. He has none. It does not exist, which means that he has no argument. And even if it was a functional gene, it would not invalidate the fusion. It doesn't magically just go away. We would try to explain why there's a functional gene there, which I think could be done. But it wouldn't matter. It's not a falsification. They want so bad that they kept arguing for years. How related to chimps? We have different numbers of chromosomes. And then when biologists actually found the smoking gun that explained why we have 46 chromosomes, they changed and moved the goalpost, because that's what the younger creationists do.
Because again, they start with a dogma, state it's true a priori, and then rationalize beyond it. And that's, again, not how scientific method is. But even so, things like these claims are constantly being tested. That's also part of the scientific process, asking scientific questions, even for things that are well established, just to check. Right? Yeah, it's just like saying with relativity, it is constantly it is frequently tested for good reason, because that's part of the scientific process, is to check and verify.
Yeah, instead of having ad hoc explanations.
Or try to refute. Yes.
Because, I mean, their ad hoc explanation for the vestigial centromere and the degraded degraded telomeric sequences are laughable. They're just saying, it just randomness. It just produced some centromere, or just, these happen to be just a random occurrence of pristine telomeric sequences. They have no explanation of why you would have telomeric repeats in that concentration in the middle of a chromosome. And what's funny is there's obviously something called a consilience of evidence. If something is true, we would expect some other things to be in consilience with it. In that, if this is a human chromosome fusion that has been two independent chromosomes that came together in a telomeric fusion, what would we expect to find? What we would expect to find is, one, telomeric repeats, which we do, and two, a vestigial or inactive or cryptic centromere somewhere along the line of one of the chromosomes, which of the human chromosome, which we do.
And as I understand it, in terms of people doing genetic research, this is not the only. We're not the only organism where this has occurred, right?
No, not by any means.
These things, and in fact, they can build this sort of history of stuff by looking at these alterations and try to start building this tree of life, which has really sometimes upended taxonomy, where they used to say, well, this thing later this thing, because they look similar.
Yeah, but they realized that they were not being precise enough, and by using better modeling, they could move species into clades they need to be in, or the phylogenetic tree.
Sure.
And humans is in the same phylogenetic tree as hominidae or hominids or great apes. We're in that tree. We are related to orangutans and gorillas and chimpanzees. And it's so funny because even back in my day, I remember them arguing at one time that dinosaur bones were put there by Satan to test us, kind of thing. It's like this is how it's
I do remember that
creationists were. But what's so funny is they haven't gotten any less crazy in their accusations. What they've just done is more technical. But to anybody that has some kind of technical expertise, all of them that can come on and have shown that the experts in the PhDs have been wrong, just like we did with Dr. Henke and Dr. Loechelt coming on to explain why Dr. Humphreys and Dr. Snellings and the rest of them, they're wrong. Because these are objective facts of the matters to be had about science. If you go learn about science, you're not going to learn about creationism science because it's not science. No university teaches it. Why? Because it wouldn't work.
It's not a scientific process, so it's not a scientific... Yeah.
Now, they could argue, well, the reason why universities don't teach it is because they're not teaching the Bible and they're not caring about salvation. Okay, sure. But so what? I don't give a crap about that either. I'll be fully...
But there's universities that have religious studies departments where that's happened. So go over there.
Yeah.
If you want that.
Yeah, you don't want it taught in science because it's not science. Creationist science simply is not science. It's a no... Stretch of imagination can be science, because when you start with a conclusion, you're no longer doing science. You're promoting a faith-based religion and then trying to comport science to that, which has failed every single solitary time. In my life, I've seen creationists claim all kinds of things, and every time they fail, they just create a new ad hoc escape hatch to try to get out of, just like flat earthers do. There's no difference. Young Earth creationism is just a more technical version of flat Earth.
Yeah, but it's a denial process. Yeah. But as I go with flat Earth, you and I had a conversation with me standing on the South Pole and performing experiments, like trying to, we always go there to try to see if I can jump off and fall off the bottom of the Earth, and every time.
By the way, he literally was jumping up and down. I mean, this is no joke. Yes. I mean, he's just like, I could hear, him being winded. I'm like, you're really actually doing it. Okay, that's cool.
Yeah, because the barometric pressure was equivalent about 5,000 meters altitude, and it was, but yes, we had the conversation on there for stuff. But
that requires a satellite, by the way, that's in orbit on an Iridium phone.
Yes.
Phone, Iridium satellite, Iridium satellite phone.
But I do. I have fond memories of our conversation there. It was a pleasure to have that. But still, it's a matter of why do I go when I go to South Pole? Why do I do the experiment? Well, because the scientific message is testing and questioning, right? It's why we build a Foucault pendulum there to check things, right? Because
I would have been really sad had you fallen off the Earth. Had you been jumped up and all of a sudden you just launched into space on live on my program. I don't think I could ever recover from that. By the way, it would be the most popular video on YouTube probably. So maybe worth it. I don't know. Do I want popularity at your dying in space because you jumped up too fast? Probably not. It's not worth it.
But as I said, the curvature of space-time also works at the South Pole, and I was, came back down. So
I'm showing.
I think it's amazing that this tree of light that they were able to construct. It's been an extraordinary accomplishment of science to do this stuff.
Because every single solitary thing in science shows this, and so Hovind. I don't know if you've watched Hovind and Arndt's debate in a while. I was watching parts of it recently, and I put it back out there. I was like, this is probably one of the greatest debates of all time. Arndt just eviscerated Hovind to no end.
And Hovind didn't understand he was being eviscerated.
He was getting creamed. Look, like I said, Arndt might not be great at philosophy, but gee, when it comes to freaking phylogenetics, the dude is unparalleled as far as him being somebody who I would consider to be a lay to intermediate expert. He hasn't. I wouldn't probably put him as the foremost expert on paleontology or phylogeny, but he definitely knows his stuff. And
I would say that he's a phylogeny communicator.
Yeah,
right?
He's a communicator. Yeah, and he's very good at communicating phylogeny. And Hovind didn't know what he was talking about. And so all Hovind would say is, this is lines on paper. Well, no kidding. We know it's lines on paper. Again, this is how they use sophistry. Young Earth creationism only exists because sophistry is a thing. And in the right tools, sophistry can be an effective tool. But when it's abused, it's just deception. It's obfuscation. It's deceptive. And so for Hovind do what's called ignorante ilice, where he's just basically saying something that's true or fallacy of a relevant thesis, it doesn't escape them from having to answer for them they think it's an escape, but it doesn't have them resolve how these things actually were shown scientifically to be the case. So when he says, these are just lines on paper, that's true, but he has not addressed any of these science, the massive amount of hundreds of years of science that went in to make this diagram, as simple as it is, true. He just throws all that away because he doesn't have the ability to really get into the complexity. So this has been distilled down to almost nothing of what you would need to know as far as the science as to why, but this is still a true diagram. We have 46 chromosomes. Bonobos and chimpanzees and gorillas have 48, but we're still in that same cladistic class of great apes. We are still an ape.
And by the way, with the scientific method, even though the current consensus is borne up with this diagram, it is still quite valid for people to test that. Right, and to check for that, because if they found something that didn't conform to this model, that would actually be quite groundbreaking, and they would discover something. So that's one of the reasons why people in research go in and continue to check. It's not a doctrine of Darwin faith, right? It is constantly under examination, and that's part of the scientific process is to continue to re-examine.
Yeah, exactly. If we found that somehow proteomically speaking, we were producing so many different proteins than bonobos, and we had no commonality of protein structures, that would be odd. But we don't find that. We find, matter of fact, one of the ways they do make these trees is by what's called cytochrome C. Why? Because in every organism we find, cytochrome C has to exist to some degree. It's part of the electron transport chain. And as we know, animals are multicellular, and what allows multicellularity animals to exist is the fact that we have this ATP produced from the electronic transport chain, and part of the complexes in the transport chain utilizes cytochrome C. So for animals to exist, cytochrome C must be present to some. Now, how it's used in different animals might differ to some degree, but it always in every single animal, for electron transport chain to be the case for respiratory function, you have to have cytochrome C. So we could trace back the differences in the structure of cytochrome C in animals, going back many millions of years, and it can still have multiple different variants of amino acids in cytochrome C and still has the same functionality, which is kind of weird. It's highly adaptive. right? It's because cytochrome C has all these mutations in it where it uses different amino acids. Believe it or not, it still functions the same in all animals.
It's a very robust process.
Very robust protein, but it still acts as a function, something in electronic transport chain to allow that anaerobic, aerobic respiration. So I have a video on ETC, electronic transport chain, which I think was still pretty good. Although I really wish I can do it now with the technology I have now. But because the information was right. It's just I'm just not a video person, man. I do live stuff.
That's a skill and
a skill set that I don't have.
That I'm impressed other people do.
Yeah, but what's funny is a lot of those people that can make really, really good videos have no live ability whatsoever. They don't have the skill set to go live. So it is what it is, right? But anyways, I think that we're probably gonna be wrapping it up here, but I think that this kind of points out that young Earth creationism is just all they do is just exploit known philosophical issues, or they just exploit the most anomalous thing to try to convince people that already believe that they're right. That's it. Yeah. Nobody's ever woke up and said, I believe in young Earth creationism that wasn't already a Christian. I don't think that's ever happened.
And I think it's because some people I suspect are so desperate that what they want to believe is true that they're willing to do all kinds of things to their intellect to try and rationalize, backfill stuff. And it really is sort of like, the fear of death and this hope for salvation forces some people to just completely up in the whole logic table. And it's a sad thing, right? That's probably one of the best things my mother did for me while she was dying was teach me about dying and overcoming the fear of that. And if you've overcome the fear of that, then you're less inclined to try and do all this apologetics to say, this must be true because I want it to be true. And therefore I'm going to go and reject everything that kind of runs counter to it. And that's
I absolutely agree with that. Yeah. And as we all get older, we know death is inevitable. We both, you and I especially, have had people we both loved and very much die on us.
Yes. And I still remember.
It hurts. It's something you never get over. And I'm
thinking about you know what I'm thinking about.
Yeah.
And I don't want to mention a name because they're
people
disgusting
people denigrate his name. And I know this, but yeah, of course, and it's not just one. There's been several people in the skeptic community. A lot of people that were related with the Non-Sequitur show have passed away, and so we as you get older, you see even famous people that you admired. I mean, one of my all-time favorite heroes of all time was the drummer of Rush, Neil Peart. When he died, my childhood went with it, kind of stuff. Even like Leslie Marie, Presley just passed away. I mean, people die. So. We all think about it, and I had a video on death and dying, but it doesn't scare me like to the point of non-functionality. It's something that it's like, okay, it's going to happen one day, whatever. I don't want to live my life in fear. But if my salvation is based upon young Earth creationism, then God's dishonest, and it's just I can't imagine wanting to be with a being like that for eternity.
Yeah, that would to me would be hell. To be in a position where I'd
rather just be no God than have a God that wants you to worship him 24 hours a day based upon lying to people and based upon manipulating science in order for the ends to justify the means. That's not a just God. Now I'm not saying there's not a just God. There might be, but it's not the God.
I don't have evidence of that.
If there is, great. There isn't, whatever. But you know what? I don't think a just God's going to care. To me, there's no way you can argue to me that a anomaly benevolent being is going to say, hey, look, you didn't have the exact right belief, therefore you're going to hell. That to me is just argumenting that.
You got the answer wrong. Yeah. As they say in South Park, you got the answer wrong. The answer was the Mormons.
The Mormon had it right. Yeah. Even though I was Mormon. Yeah. The Mormons had it right.
But again, I think, now this isn't to say that you can't be religious and be a scientist, right?
Of course.
There are some very good things.
Yes.
I think the thing you that's difficult to do is to be a scientist and to describe to some of this, backfilling dogma that the creationists seem
like
to
I
do.
said, this is why I accept old Earth creationists as scientists, but I will not accept young creationists as scientists. And I know, like I said, I know many of them. I get along with them. I don't think they're bad people. Some of them, I think, like
Yeah.
I think that they believe something very, very strongly to the point where they've crippled themselves. I mean, because you got like people like Dr. Safadi, who's genius. That dude is smart as hell.
Yes.
But he's
amazing.
also, he starts with the premise that young Earth creation is true, and nothing will convince him otherwise. No science, nothing will ever convince him otherwise. He signs a waiver of that. Same the people that work at the Ark Encounter, they have to sign a waiver that they accept young Earth creationism, and nothing will ever convince them otherwise. And that there's no science that says otherwise. They have to sign a statement of faith to even work there. That's a cult, by the way. That is a cult.
Yeah.
There's no other way to describe that. That's a cult.
It's one of the aspects. One of the aspects of cult modeling, if you use the bite model, those are some of the things. Yes.
Yeah, I absolutely.
But again, I don't think if you're a person of faith, I'm not laughing at your faith.
No.
And I don't think that faith and science are irrevocably opposites. I think, however, if you try to rationalize faith through apologetics in an unscientific way, it's difficult to be unscientific on your apologetics and to be scientific someplace else. That requires a really extraordinary bit of leaping to that. So again, I don't want to come off as being anti-religious, but personally, I lack the belief of there are no gods, and I lack the belief there is a God. Right? I'm in that spot where you would say, I'm agnostic.
Mm-hmm.
I can speculate, but that there is no gods, I don't see evidence for that. But that's a thing.
Yeah, there's nothing wrong with that. Like, I mean, I've already said I don't believe that the way the Christian God is described, the theistic Christian God exists. I believe that particular God does not exist. But my view on philosophy is a lot more complicated, as you know. But I mean, yes. I've actually taken the time out to think about these things. Right? I have not just did a cursory view on a lot of stuff. I've taken years of my life.
Stuff. You read a lot of literature. You've actually talked to some of the important people in that subject, and you published in that subject as well.
So I've actually spent some time thinking about this. Right? It's not necessarily willy-nilly my position, but my position is not simplified, and nor it should it be, and that doesn't matter. That it doesn't matter. What matters is that neither Landon nor I will ever say we have such truth of the matter when it comes to religion that everybody else is wrong. That's never going to happen. What we will say this, though, we have the truth in science that if your religion is predicated on things like young Earth creationism, then your religion is wrong.
You have a problem with science, right?
Yeah.
And I think again, it's a matter of saying that if you're going to have faith, understand where it falls in respect to other processes, other things like the scientific method, and I think it's easier to have something that's more compatible. But still, from a high level point of view, it's the scientific method works. I agree effectively with Laplace, who when the legend is when Napoleon said, on all this math stuff, where's God? And his answer is, I had no need for that hypothesis. He wasn't saying I have no need with God.
Yeah.
It's just that
for science,
if you're talking about, how is the universe doing what it's doing? I don't need a God or gods to have a universe.
Yeah.
Right?
And I don't even have a problem with young creationism. Like if they believe that the Earth is young, and then they do try to do the science to explain that. I don't even have a problem with that. That's actually doing science. But the problem is then when the science goes against what they believe, that science is discarded as wrong. That's not science at that point. Yeah. Because if you had two independent people, and I said, hey, person A and person B, I want you both to go. You're experts in your field. Go tell me what the age of the Earth is independently. They both could do that by using experiments and numbers, and both of them will objectively come up with this around the same range independently of each other. There's an objective fact of the matter to be had, right? Mm-hmm. Even young Earth creationists, by using those methods, will come up with the same answer as the rest of them, that the age is old. They even admitted this, that radiation decay indicates an old Earth. But the young Earth creationists, being with their precept that the universe must be young, then has to say, well, that information, that science that you say is objectively true, is wrong, and then they come up with ad hoc reasoning as to why it's wrong. They don't come up with any scientific reasoning. They come up with ad hoc reasoning, and that's the difference. But anyways,
but again, it's important to test that stuff. So I don't mind people testing it.
No,
what I mind is people falsifying without a test.
Yeah, and that's to me is lying. Well, look what happened. Yeah. We'll end this, but look what happened when Jeranism tested the flat Earth experiment that they were doing. He said, okay, the Earth is flat. If we did this experiment, this would determine whether it's flat or not. They did the experiment and determined it was round, and he's just like, interesting. It's like, no, dude, it's more than interesting. It disproved your own hypotheses. Yes. But of course, the flat earthers still have to go, oh, well, the experiment failed, and then say, again, the abominable snowman argument that, the abominable snowman blew the air in such a way that it caused, these isotope
light,
ducting and things of that nature. It's just ad hoc. But I'm going to call the heat problem resolved by the abominable snowman hypothesis. I came up with that, so we're going to keep that. Abominable would be abominable snowman hypothesis. ASH. The acronym sucks.
And of course, the other side is the abominable lava man, which by the way is going on.
Oh, but you know what? It could be this though. ASC is the asynchronous synchrony convention, right? ASC is what Lyle has. Mm-hmm. Well, I could just change that as the abominable snowman convention. There you go. ASC. It works. Yes. So ASC works by the Abominable Snowman Convention. That works out brilliant, actually, to refute Lyle's ASC convention. My ASC refutes his by ad hoc convention. Anyways, Len, stay in the
Thank you very much.
Stay here for a minute because I do got to ask you something off air. Relating to your contact stuff. But everybody else, thanks for watching this. If you guys got any questions, please leave them in the video description. Can I ask everybody who watched this and has watched it to start sharing these things on their social media? It really does make a difference. People have been watching these things and getting more involved, especially on Facebook and other places. So if you want to support this channel, by all means, become a Patreon, become a member. You get a green name. And if you can't afford that or anything like that, just share these videos. It means a lot.
Or even click the like button. That helps.
That helps
if you like what you heard.
Every little bit helps.
If you dislike what you heard, click the
if you don't like what you heard, go somewhere else. No, I'm kidding. Dislikes are taken away. They don't even have dislikes anymore. They took them out.
Oh, they did. What's that thumb down button do?
They have that on the video comments, but that doesn't do anything. It used to do something, but I guess they took away the functionality of that. But they took away the thumbs down on the videos. But but anyways, like I said, all the people out there, please share this on social media, Facebook and Facebook groups and Twitter. And not just this video, but all these videos that I'm doing recently on younger creationism. I want them promoted, especially because I am going to be doing science for a while, because I think I've done enough philosophy for a while, even though I'm not going to stop doing philosophy, but it's just going to be more rare. I think I want to get back into the younger creationist stuff because I love debunking that stuff.
I will point out that I still recommend you write a commentary paper on the paper you did.
One of these days I might. I really
because I think there you could address some of the valid comments.
Yes.
Not refutations. No one refuted your paper, but valid comments, and you can also help amplify some of the points that might.
And I still plan to one of these days. I want to write a second paper on agnostic atheism, but I just been.
Yeah, and so yes, I understand. I think there's value in you doing that at some point. But yes, getting back to science, I would encourage you to consider that. And again, people can know you become a patron. I'm a patron of yours, and you can effectively buy him a coffee or whatever.
I like my coffee. I love coffee.
Yes, and I actually well-made coffee too. I hope you have a good.
My coffee maker is amazing. When I did the show, Agree to Argue with Reasons to Believe, when I left the show because they couldn't. The show was originally meant to be done in studio. They were making a model, they were making a set. But unfortunately, because of Covfefe, it had to be done online, and so it didn't get the push that it needed. But it ran its course. We were only going to do it for a year, anyways. That was established from day one, that they only were going to fund this for about a year, and it wasn't going to be renewed. And so I knew it had a shelf life. But when it was over, they gave me this Black & Decker Vortex coffee maker because they knew I loved coffee with a couple things of Turbo X coffee, 3 times Turbo X coffee. And I ran out of the coffee because I used it all, but I still have the coffee maker, and it's amazing. All right, but anyways, like I said, stick around. Guys, thanks for watching this. Like I said, if you leave comments, I really appreciate it. Let me know what you think. I will address things in real time. The Young Earth Creationists were invited to join us. They know my channel. They know they can come on anytime, but none of them have showed up. So my apologies.